Good morning. You're looking at a live view of NASA's Space Launch System moon rocket on Launch Complex 39B at Kennedy Space Center in Florida. Today, NASA's Artemis 1 launch team plans to load more than 750,000 gallons of cryogenic propellants into the moon rocket on pad 39B. This is a tanking test today designed to verify that a leak in the hydrogen loading system that was detected earlier this month and cut short a launch attempt on September 3rd has been resolved. These hydrogen leaks have been a pesky issue for NASA's Artemis 1 team over the last few months. They've cropped up during tanking tests and cryogenic loading demonstrations and countdown rehearsals, and then it cropped up again in a more significant way. A more significant leak was discovered on the September 3rd launch attempt for the Artemis 1 mission. If you were watching that as it happened, you'll know that the countdown was scrubbed, and NASA decided to call off launch attempts for the Artemis 1 mission for at least several weeks once the launch window actually closed on September the 6th. And the team at Pad 39B spent the last couple of weeks making repairs to the quick disconnect area where hydrogen is loaded into the core stage near the bottom of the rocket. They replaced seals in two different lines, an 8-inch line and a 4-inch line in the tail service mast umbilical area. This is the area near the bottom of the core stage again, where liquid hydrogen is loaded into the rocket during the fueling operation. And today, the team will be loading propellants into the rocket to help verify that that leak is resolved and those repairs worked. And this potentially lays the groundwork for a new launch attempt for the Artemis 1 lunar test flight as soon as next Tuesday, September the 27th. There are some caveats to that. Most significantly, the eastern range here at Cape Canaveral has to approve an extension to the battery certification for the Space Launch System's flight termination system. This FTS is the range safety destruct mechanism that would be used to terminate the flight and essentially blow up the rocket if it veered off course after liftoff. The battery for this system was initially only certified for 20 days. The range did extend that certification for 25 days to enable a series of launch attempts in late August and early September. And NASA has gone to the range again to ask for another extension to their certification. NASA engineers are providing data on the behavior and characteristics of the batteries on the flight termination system in order for the Space Force to make that determination on whether they're going to approve the certification extension that has been requested by NASA. So a lot of uncertainties involved with determining when NASA will again attempt to launch the Space Launch System moon rocket and the Orion spacecraft on this unpiloted test flight around the moon. But NASA engineers hope that at least one of those uncertainties, the issue involving the hydrogen leak, will be cleared today if the loading demonstration goes well. Right now, the countdown clock is holding at T-minus 6 hours and 40 minutes. And we expect in the next half hour or so to hear word from NASA on the outcome of meetings this morning by the mission management team, as well as the Artemis 1 launch team. The chair of the mission management team, Mike Seraphin, and the launch director, Charlie Blackwell Thompson, are expected to give their go or no-go for the cryogenic tanking test. If all technical parameters and weather conditions are indeed acceptable to proceed this morning, we expect to hear the go from the launch director around 7 a.m. Eastern time. That's a little more than 20 minutes away. NASA's launch team is taking what they call a kinder, gentler approach with tanking this morning. They've adjusted some of the timelines and procedures for loading propellants into the Space Launch System. And these are designed to reduce the stress on seals and quick disconnect fittings that have been prone to leaks during previous tanking operations. The approach involves essentially slowing the rate at which they increase pressure and flow rates during the start and the early phases of tanking operations. Liquid oxygen and liquid hydrogen will be loaded into the vehicle initially in what's known as slow fill mode, and then both of those propellants are transitioned into fast fill mode. The plan today is to load propellants into the core stage and the upper stage of the Space Launch System. That totals about 755,000 gallons of cryogenic fluid. The vast majority of that goes into the core stage. The weather parameters for loading cryogenics into the Space Launch System primarily are concerned with the risk of lightning. There must be no greater than a 20% chance of lightning within 5 nautical miles of the launch pad in order to proceed with the start of propellant loading. There are some thunder showers just off the coast of Cape Canaveral this morning. The weather team, we expect, is monitoring those thunder showers as they actually are drifting very slowly toward the coast right now. We have not heard any official weather briefing yet this morning, so it's not clear if those showers contain lightning and if those are going to be encroaching within the 5 nautical mile ring around the pad. But all this will be briefed to the launch director, Charlie Blackwell Thompson, before she determines whether the launch team will be go or no go to start propellant loading on time this morning. The plan, once propellant loading gets underway, is to continue the countdown all the way until what's known as the T-minus 10-minute hold. The countdown will not enter the last 10 minutes. The Artemis countdown actually includes 2 built-in holds, one of which is at T-minus 6 hours and 40 minutes, and that's where the countdown clock is holding right now. That hold started at 6 a.m. Eastern time and is expected to end at around 8:30 a.m. Eastern time or 12:30 UTC. And the clock will resume ticking at 8:30 if all is going on schedule. And once the propellants are fully loaded onto the Space Launch System, the launch team hopes to get all 4 propellant tanks into what's known as stable replenish mode. That's when the tanks are fully loaded and the loading of propellants will continue to flow into those tanks in the replenish mode to essentially replace the liquid hydrogen and liquid oxygen that naturally boils off in the warm Florida air here at Kennedy Space Center. And once all those tanks are in replenish mode, the team will hold there for a little while to monitor the systems before the tanking test is ended around 3 p.m. Eastern Time or 1900 UTC. That's the expected end time for today's tanking test if the tanking gets underway on schedule this morning. While we wait for news on the status of today's tanking test, if you haven't had a chance to do so, please hit the like button here on our YouTube channel. And on this stream, it helps us gain a bigger audience for our coverage of today's Artemis 1 tanking test. NASA's Artemis 1 launch team is stationed in Firing Room 1 of the Launch Control Center at Kennedy Space Center this morning. We're awaiting the go from Launch Director Charlie Blackwell Thompson to proceed with cryogenic loading operations on the Space Launch System this morning. The weather team has been monitoring some showers and thunderstorms, mainly offshore of the Cape Canaveral and Kennedy Space Center area. Right now, the weather outlook is go to proceed with cryogenic tanking on time this morning. However, NASA says the forecast is, quote, borderline. There is a 20% chance of lightning within 5 nautical miles of the launch pad in the next few hours, and the requirement, the weather criteria to continue into cryogenic loading operations requires that that chance of lightning not exceed 20%. So indeed, it is a borderline forecast for cryogenic tanking to begin on time this morning. NASA's launch team is holding off a bit this morning on the start of cryogenic tanking due to the presence of a red team out at the pad. That team was dispatched to the pad 39B area to troubleshoot a problem during pressurization of an electrical room on the mobile launch platform. These rooms, these parts of the mobile launcher are pressurized with gaseous nitrogen as part of a purge to ensure there's no risk of any buildup of flammable gases during the propellant loading process. That issue has been resolved, apparently, according to NASA, but the team is still making their way away from the pad. And once they're outside the blast danger area, which extends to a radius of about 4,500 feet from the pad 39B area itself, the launch team will give the go to start propellant loading operations. And that will begin with the chill down of the liquid oxygen transfer lines that lead from the ground storage tank up to the mobile launch platform. You're looking live at the press site countdown clock at Kennedy Space Center. You can see the Space Launch System moon rocket in the background off to the left. We're waiting for the go from Launch Director Charlie Blackwell Thompson to proceed with this morning's tanking test. NASA's launch team has given the go for the start of cryogenic loading this morning. This was given about 30 minutes behind schedule, so we'll see how soon the propellant loading operation actually begins. The timeline called for liquid oxygen transfer line chill down to begin at 7:25 a.m. Eastern Time. We're now about 5 minutes past that timeline, but there typically is a bit of wiggle room in the schedule. So we'll see if they'll be able to start that process soon, now that the go has been given by Launch Director Charlie Blackwell Thompson for cryogenic loading at Pad 39B at NASA's Kennedy Space Center in Florida. NASA's launch team has just begun a procedure known as liquid oxygen transfer line chill down. This is the first step in cryogenic tanking this morning out at pad 39B and involves thermal conditioning of the cross-country transfer lines that lead from the liquid oxygen storage tank to the mobile launch platform. This process involves flowing just a little bit of liquid oxygen from the ground storage tank through the lines that lead up across the launch pad up to the launch platform. And these transfer lines are the lines that will be used to actually flow propellants into the core stage when that time comes later this morning. So again, liquid oxygen transfer line chill down is now underway. That will be followed by the start of liquid oxygen loading on the core stage, first in slow fill mode and then in fast fill mode. And then per the expected timeline, right now we would be about an hour or so away from the chill down of the liquid hydrogen transfer lines, followed by the slow fill and fast fill of liquid hydrogen into the core stage. That will be one of the critical steps or critical milestones that will be closely watched this morning as hydrogen begins loading into the core stage, because that flows through the 8-inch fill and drain line where the team encountered a leak during the September 3rd launch attempt. That leak has been repaired, engineers believe, by replacing a seal in that quick disconnect fitting where the plates on the mobile launch platform umbilical and the core stage itself actually come together. That's where the leak was. And the team believes that replacing that seal hopefully has fixed the leak. When they took that seal out, they found an indentation that was about 0.01 inches in size, a very small mark on that seal that is consistent with the leak indication that the team saw during the September 3rd launch attempt. However, they aren't totally sure, 100% certain if that was the cause of the leak. And part of today's tanking test is to verify that. It's difficult to find a leak in a hydrogen system because liquid hydrogen is one of the smallest molecules known, and it's also chilled to minus 423 degrees Fahrenheit, and seals and gaskets, when subjected to cryogenic temperatures at that level, super cold temperatures, can actually contract and change shape and can create a leak path that did not exist at ambient temperatures. So exposing this quick disconnect seal, or QD seal, to cryogenic conditions and the small molecule that is LH2, the liquid hydrogen, two hydrogen atoms bonded together, hopefully will reveal that there's no leak in this connection, and that would allow the tanking operation to proceed this morning. If you're just joining us, you're looking at a live view of Launch Complex 39B at NASA's Kennedy Space Center in Florida. This view comes from a camera on the west side of the launch pad looking east. To the left of the vehicle here is the mobile launch platform, and to the left of that is the water tower used for the sound suppression system out at pad 39B that will release water onto the deck of the launch platform during the final seconds of the countdown on launch day. But again, today is not a launch day, it's a tanking test designed to validate and verify that the hydrogen leak that cut short, scrubbed a September 3rd launch attempt for the Artemis 1 mission has been fixed. And if all goes well, NASA will proceed through the entire tanking operation today. That will include the testing of the engine Kickstart Bleed later in the countdown this morning. That's the procedure that flows a little bit of liquid hydrogen through the engines and into the engine compartment to thermally condition those RS-25 core stage engines down to the proper cryogenic temperature for ignition. This Kickstart Bleed procedure has also been a bit of an issue during the previous wet dress rehearsals, namely on June 20th, when there was a leak in the line in the quick disconnect area that actually flows this hydrogen into the engine section for the Kickstart Bleed. That leak was fixed when the rocket returned to the vehicle assembly building, and then was rolled back out in August for the series of launch attempts, first on August 29th, and then on September the 3rd. Obviously, the Space Launch System did not get off the ground on those attempts. On the August 29th launch attempt, there was an indication in some data from one of the engines that it was not reaching the proper temperature for ignition during this Kickstart Bleed procedure. It wasn't quite getting cold enough. However, NASA engineers determined that likely was due to a sensor problem and not an actual problem with the Kickstart Bleed procedure. So engineers will be looking to other readings, other data from other sensors around the engine area to verify that all four engines do reach the proper thermal conditions for ignition during the chill down Kickstart Bleed procedure this morning. But that will come after, or once the liquid hydrogen begins loading into the core stage. So a few milestones to closely watch that have caused trouble during previous countdowns. And NASA hopes for a much smoother operation this morning. You're watching a view from one of NASA's engineering cameras out at Pad 39B, panning up and down the core stage of the Space Launch System moon rocket. These cameras are used to monitor the condition of the rocket during cryogenic tanking operations. And we're getting some of these feeds direct from NASA this morning. If you're just joining us and you haven't had a chance to do so, please hit that like button on YouTube. It helps us gain a bigger audience for our coverage of today's Artemis 1 tanking test. So please hit the like button on YouTube. It's a really nice view looking up at the Orion spacecraft on top of the Space Launch System. The crew access arm is extended up against the side hatch of the Orion spacecraft. And we're back to a view now of from one of the engineering cameras panning down the core stage, which is covered in this spray-on foam insulation with its familiar orange butterscotch color. On the left-hand side here, you can see the liquid oxygen feed line, which actually flows the liquid hydrogen, or liquid oxygen rather, from the tank near the top of the core stage down into the engine compartment. This LOX, or liquid oxygen feed line, is also used for loading of liquid oxygen into the core stage. And once the loading begins, that's when the propellant chilled down to nearly 300 degrees below 0 Fahrenheit will be flowed through that line up into the liquid oxygen tank on the core stage. And when that happens, we expect to see some vapors and condensation and then some frost form at different points along that line. We're not seeing that yet because tanking is not yet officially underway, although tanking operations and preparations are underway at Pad 39B with the chill down of the liquid oxygen transfer lines on the ground side. NASA says that chill down of the liquid oxygen transfer lines is now complete. So that's the first step in today's cryogenic loading operation. This involved flowing a little bit of liquid oxygen from the ground storage tank into the lines that lead up to the launch platform, but not yet into the rocket itself. And now chill down of the main propulsion system on the Space Launch System core stage is beginning. This will flow some of that liquid oxygen through the engine compartment to begin the process to bring those engines from their ambient temperature in the warm Florida air here at Kennedy Space Center down to ultimately down to roughly minus 400 degrees. Some of those components will reach that temperature as the liquid propellants flow into the engines for preparation for ignition. That chill down will continue throughout the day, first with liquid oxygen, then with liquid hydrogen. Again, today's tanking test will culminate in the completion of full propellant loading on the Space Launch System. Both stages will be filled today, but the countdown will be stopped at about the launch minus 40 minutes mark as the countdown reaches the built-in hold at T-minus 10 minutes. The countdown will not enter the terminal countdown from T-minus 10 minutes on. The Orion spacecraft on top of the Space Launch System stack, as well as the 2 solid rocket boosters, are not powered up for this morning's operation, but the core stage and the upper stage are powered up and active because those are the elements that will be loaded with cryogenic propellants today. We expect to see this countdown clock pick up in about 8 minutes or so at 8:30 a.m. Eastern Time. This clock will resume ticking from T-minus 6 hours and 40 minutes. This is a pre-planned built-in hold, just as the countdown will be held at this point on launch day. As you can see, the countdown clock has resumed at T-minus 6 hours, 40 minutes and counting. This ends the 2.5-hour built-in hold in today's tanking test countdown. The next step this morning will be the start of a slow fill of liquid oxygen into the core stage of the Space Launch System moon rocket. We're standing by for confirmation of that milestone. We've just heard confirmation from NASA's Launch Control Center that the chill down of the liquid oxygen transfer lines has been completed, and the slow fill of liquid oxygen into the core stage is underway. This liquid oxygen is flowing into the rocket through what's known as the tail service mast umbilical near the bottom of the vehicle. That's the connection between the launch platform and the core stage itself. About 196,000 gallons of liquid oxygen will be pumped into the core stage this morning for this tanking test. So propellant's now officially loading into the Space Launch System today at pad 39B. The launch team is also go for the start of liquid hydrogen loading operations. This will begin with the chill down of the liquid hydrogen transfer lines, a similar procedure that we talked about a few minutes ago with liquid oxygen. This time it'll be the liquid hydrogen lines that'll be chilled down, the transfer lines leading from the ground storage sphere up to the mobile launch platform, and that will be followed once those lines are properly conditioned with slow fill of liquid hydrogen onto the SLS core stage. This view you're looking at now from Launch Complex 39B shows the tail service mast umbilical area. On the right-hand side is the liquid hydrogen umbilical. On the left is the liquid oxygen umbilical. Liquid oxygen is currently flowing into the core stage through that umbilical on the left-hand side. It's still loading in slow fill mode. This will be transitioned to fast fill shortly. On the right-hand side is the liquid hydrogen umbilical. That's where liquid hydrogen will flow into the vehicle, first in slow fill mode and then in fast fill mode. And the umbilical plate, where that umbilical line actually enters the vehicle, is where the large hydrogen leak was detected back on the launch attempt on September the 3rd. In the last few weeks, technicians at the pad disconnected that umbilical. They replaced a seal, actually two different seals, one in the 8-inch fill and drain valve that the leak was found in. They also replaced a seal in a 4-inch line as a precautionary measure. When they took off the seal from the 8-inch fill and drain line valve, they found a small indentation. It was a tiny mark, just about 0.01 inches, 1/100th of an inch in size. That may be indicative of the cause of that leak during the September 3rd launch attempt, but nevertheless, a new pristine seal was installed. And then the technicians reconnected the umbilical plates, the flight side plate on the rocket itself and the ground side plate on the tail service mast umbilical that will disconnect when the Space Launch System lifts off. And today's tanking test is intended to verify that that seal is tight and there's no hydrogen leak present. The limit, the safety limit, is no more than 4% concentration of hydrogen in that umbilical area. In this wider view of pad 39B on the lower left, you're seeing the lower left of the vehicle is the tail service mast umbilical. That's where we were just looking at a few moments ago in the tight view, in the up close view. This is a wider view showing the big picture out at pad 39B with the Space Launch System towering 322 feet tall. It's about 98 meters in height, sitting on its mobile launch platform. And again, that tail service mast umbilical where the propellants are flowing into the vehicle is that hut or raised appendage sticking above the deck of the launch platform. And that umbilical housing contains two umbilical connections, one for liquid oxygen, one for liquid hydrogen. NASA has just confirmed that liquid hydrogen loading is now in slow fill mode. This is the first step to begin loading liquid hydrogen into the core stage. If you're just joining us, please hit the like button on our YouTube stream. It helps us gain a bigger audience for our coverage. You're looking at a live shot from the Kennedy Space Center press site showing the countdown clock having just passed T-minus 6 hours for today's Artemis 1 tanking test. Again, this tanking test is designed to verify there are no leaks in the hydrogen loading system in the tail service mast umbilical. That's the main goal of today's test. It also offers another opportunity for the team to check out the Space Launch System and ground systems to gain confidence that that hardware and software are ready for the next launch attempt, which could happen as soon as next Tuesday, September 27th. But that schedule makes a couple of assumptions It assumes that today's tanking test goes well, that there are no leaks, and it assumes that the Eastern Range, which is the U.S. Space Force's division that oversees public safety and range safety for all launches from Cape Canaveral Space Force Station and Kennedy Space Center, approves an extension to the battery life certification for the Space Launch System's flight termination system. This flight termination system is the destruct mechanism that would be used to destroy the vehicle if it veered off course after liftoff. That battery life certification has expired, but NASA has proposed to the Eastern Range and requested an extension to that battery life certification. That proposal and request is now under review by the Space Force. If the Space Force does not approve that extension, then the Space Launch System moon rocket would have to be rolled back to the vehicle assembly building for another round of testing and checks on that flight termination system, also known as the FTS. And those FTS checks can only occur with the rocket inside the VAB. They cannot occur with the Artemis 1 moon rocket out at Launch Complex 39B. In that case, the launch would likely be delayed till the end of October at the very earliest, and could force a delay into the following launch period, which opens on November the 12th. While we're covering the Artemis 1 tanking test at Kennedy Space Center in Florida, we're also monitoring activities over at the Baikonur Cosmodrome in Kazakhstan, where a Soyuz rocket is counting down to liftoff at 9:54 a.m. Eastern Time. That's 13:54 UTC, with the next three-man crew heading to the International Space Station. This is a live view from the Baikonur Cosmodrome, where the Soyuz rocket is now fully loaded with kerosene and liquid oxygen propellants, and the three-man crew has boarded the Soyuz MS-22 spacecraft on top of the vehicle. Two Russian cosmonauts, Sergei Prokopyev and Dmitry Petelin, will be joined by NASA astronaut Frank Rubio for today's flight to the International Space Station. They'll be heading to the ISS to begin a half-year expedition in orbit. Frank Rubio is the first NASA astronaut to fly on a Russian Soyuz spacecraft since the recent signing of a so-called seat swap agreement between NASA and the Russian space agency Roscosmos. This is an in-kind or barter agreement between the two agencies to allow U.S. crew members to continue flying on Soyuz spacecraft and allow Russian cosmonauts to fly to the space station on Crew Dragon spaceships from SpaceX. So a three-man crew heading to the International Space Station today on a roughly 3.5-hour rendezvous from the time of liftoff until docking at the ISS. Docking at the International Space Station is planned at 1:11 p.m. Eastern Time, 17:11 UTC. So launch is now about 35 minutes away, and we'll bring that to you. We hope to bring that to you on this stream during the final moments of the countdown and the beginning of the climb into orbit for the Soyuz rocket and the Soyuz MS-22 spacecraft with these three crew members. We're back live at the Kennedy Space Center, looking live at Launch Complex 39B, where NASA's Artemis 1 moon rocket is standing. Liquid oxygen and liquid hydrogen are both now loading into the core stage. Liquid oxygen now is in fast fill mode. Liquid hydrogen is in slow fill mode. It's a live shot of the gantry arms opening at the Site 31 launch complex at Baikonur in Kazakhstan. This is a milestone in the countdown that typically occurs about a half hour before launch, and we are indeed 33 minutes from liftoff now of the Soyuz rocket from Site 31 at the Baikonur Cosmodrome, carrying the next three-man crew to the International Space Station, two Russian cosmonauts and a U.S. astronaut on board. This view from Launch Complex 39B is from a camera attached to one of the three 600-foot tall lightning protection towers at the launch complex. These lightning masts are there to protect the Space Launch System moon rocket while it's out at the launch pad. As you can see, there's no gantry structure, no mobile service tower to protect the vehicle while it's out at the pad. So these lightning towers were erected now more than a decade ago in the very early stages of modifying Pad 39B for the launch of a future heavy lift rocket after its previous use in the space shuttle program. You're looking to the southeast from this lightning tower toward the Space Launch System with its mobile launch tower next to it. In the distance off to the right is Launch Complex 39A, where SpaceX currently launches Falcon 9 rockets, including crew missions to the International Space Station on the Crew Dragon spacecraft. And you can also see on the horizon there, the launch tower now fully assembled, fully stacked for the next generation Super Heavy and Starship rocket program. This is the fully reusable commercial rocket in development by SpaceX. SpaceX plans to launch the Starship, which itself is a super heavy lift rocket, actually with a bit more performance than the Space Launch System. The first Starship orbital test flight is set to lift off from SpaceX's Starbase facility in South Texas, potentially later this year. Elon Musk has said this morning that that orbital test flight, he believes, is now, quote, highly likely, unquote, to occur in the November timeframe. However, the first test flight of the first orbital test flight of the Starship has been delayed by months as SpaceX continues testing boosters and Starships on the ground at Starbase. So we'll see how that schedule evolves in the coming weeks. Here's a view of Pad 39A, a better view of Pad 39A with that Starship tower now standing more than 450 feet tall next to the shorter pre-existing launch tower fixed service structure for the Falcon 9 and Falcon Heavy rockets with the crew access arm extended. The next launch from this pad will be no earlier than October 3rd with the next crew mission, the next US crew mission to the International Space Station on the Crew Dragon spacecraft. This morning, another crew is set to launch from the Baikonur Cosmodrome in Kazakhstan at 9:54 a.m. Eastern Time. That'll be a team of 2 Russian cosmonauts and 1 US astronaut on the Russian Soyuz MS-22 spacecraft. That launch is now less than 20 minutes away. We'll bring that to you live on this stream as we get closer to that liftoff. We're now looking again live at the Baikonur Cosmodrome in Kazakhstan, where the Soyuz MS-22 spacecraft is less than 3 minutes from launch, carrying 2 Russian cosmonauts, Sergei Prokopyev and Dmitry Petelin, as well as NASA astronaut Frank Rubio, on a flight to the International Space Station. They're set to launch from the steppes of central Kazakhstan, Central Asia, in about 2.5 minutes' time on the Soyuz MS-22 spacecraft. They'll begin a 6-month expedition on the International Space Station. It'll take about 9 minutes for the Soyuz rocket to do its job to place the 3 crew members and the Soyuz spacecraft into a preliminary orbit, and that'll set the stage for docking at the ISS a little more than 3 hours after launch. So we're going to go live to the Baikonur Cosmodrome now. We're going to bring up audio from NASA TV commentator Rob Navius, who will talk us through the remainder of the countdown and the initial climb into space.
Passing through 2 minutes, coming up on the termination of the ground propellant feed to the Soyuz booster. T-minus 1 minute 30 seconds until launch. The Soyuz about to go on internal power. This in-cabin view showing at the bottom of your screen Sergei Prokopyev, the Soyuz commander, and at the top of your screen Dmitry Petelin, Frank Rubio on the right of Prokopyev out of the field of view here. We are now 50 seconds from launch.
Vehicle switch to internal power, first umbilical tower separation.
First umbilical should be retracting, and there it goes. The second umbilical will retract at about the T-minus 15 second mark. The second umbilical has retracted. This will initiate the auto sequence start. T-minus 10 seconds and counting. We have engine start.
Umbilical tower separation.
Turbo pumps coming up to flight speed.
Turbo pumps, flight speed,
and liftoff. A sunset start to the mission of Rubio, Prokopyev, and Petelin to the International Space Station.
10 seconds, flight is nominal.
Good first stage performance reported from the blockhouse at Baikonur. The Soyuz delivering 930,000 pounds of thrust from its 4 boosters and single engine.
L plus 20, L plus 20.
Arcing out to the northeast from the Baikonur Cosmodrome. 35 seconds into the flight. Everything looking good so far. Good roll, pitch, and yaw program. The vehicle reported structural stability is good. Approaching the 1 minute mark into the flight.
Crew is feeling well. Vehicle is nominal. Copy.
Velocity now about 1,100 miles per hour. Yaw, pitch, and roll program all reported to be nominal from the blockhouse at Baikonur.
Nominal. Vehicle is nominal. Crew is feeling well.
Prokopyev reporting the crew is feeling well. Coming up on the 1 minute 20 second mark into the flight. Now passing through the area of maximum dynamic pressure.
L plus 80 parameters are nominal.
One minute 35 seconds into the flight.
Pressure in KPO parameter is above nominal. Copy, casual parameter of nominal. Correct? Affirmative. There's that. Jettison confirmed.
And we've had first stage separation.
Nominal. Crew is feeling well. KZO pressure parameter is nominal. Copy. KZO is nominal. Please report pressure. 8358. 834.
2 minutes, 35 seconds into the flight.
Second stage engine operating nominally.
The second stage engine is operating normally. Now a view from the upper stage of the Soyuz booster as it continues to climb uphill. Launch shroud now has been jettisoned.
Vehicle is nominal.
The Soyuz booster about 48 miles in altitude. Traveling about 5,200 miles an hour. Some 72 miles downrange.
L plus 190.
3 minutes, 20 seconds into the flight.
Is nominal. C indication controlled descent available. Vehicle is nominal. Copy. Indication is on.
Well, good reports so far. The flight reported as nominal as we approach the 4-minute mark into the flight.
Pressure reached 105,1500 for a moment. Copy.
Second stage engine continues to burn as planned as we approach the 4-minute, 15-second mark into the flight. About halfway through powered flight now.
Copy.
About 15 seconds away from second stage shutdown and the ignition of the third stage.
L plus 270. Parameters are nominal. Second stage separation confirmed.
Second stage shutdown and separation is confirmed. The Soyuz now climbing to orbit on the singular power of its third stage engine. 5 minutes, 12 seconds into the flight, about 3.5 minutes of powered flight remaining.
L plus 310. Launch vehicle is stable. Vehicle is nominal. Crew is feeling well.
Prokopiev reports that the crew is doing well. This third stage engine providing 67,000 pounds of thrust for the remaining 3 minutes of powered flight. We've now hit the 6-minute mark into the flight, everything going as planned. A true trajectory so far for the Soyuz booster. Now flying on the third stage propulsion of its singular engine. Good roll, pitch, and yaw reported. Good structural stability reported.
$380 seconds. The engine of the third phase is working nominally. $400 seconds. The stabilization of the article is in place. It is stable. Altai.
good structural stability of the Soyuz vehicle at the 7-minute mark into the flight, about 1 minute 45 seconds of powered flight remaining. Yaw, pitch, and roll all reported to be nominal. At the time of third stage shutdown and spacecraft separation, control of the Soyuz vehicle through docking will transition to the flight control team at the Russian Mission Control Center outside of Moscow. Seven minutes, 30 seconds into the flight. Again, this view from a camera on the upper stage of the Soyuz booster, which should also provide us a view of the solar array deploy shortly after spacecraft separation.
Nominal crew is feeling great.
The crew reported to be feeling great, in the words of Sergei Prokopyev, the Soyuz commander. We have now reached the 8-minute mark into the flight, 45 seconds away from third stage shutdown and spacecraft separation.
480. The parameters of the launcher is nominal, and everything is nominal on orbit, and the crew is feeling great. We're waiting for the separation.
The crew on board the Soyuz MS-22, Rubio, Prokopyev, and Patelin, now about 15 seconds away from third stage shutdown and spacecraft separation.
10 seconds. $520.
And we have third stage shutdown and spacecraft separation. You see the third stage dropping away. Time tag commands now will deploy the solar arrays and the navigational antennas.
Altai,
Moscow. Altai, Moscow.
And we now have confirmation of a perfect solar array and navigational antenna deploy. The Soyuz MS-22 now in its preliminary orbit, and the chase has begun to catch up to the International Space Station, with docking planned just 3 hours from now after a 2-orbit journey. Docking scheduled at 12:11 p.m. Central Time.
Moscow, how do you read us? Altai, Moscow. If you read me, if you can copy me, then please continue per page 35 and start AKG. Altai 2, how do you read it? RP1, RP2 is closed. Yes, RPV1 and RPV2. Yes, what about the separation contact? How did it go? It went nominally. How do you read me? This is Altai 1. Altai 1, read you loud and clear, and we copy. Everything went nominally. Yes, there was a drop in comm and a delay in comm for a little bit. Now everything is nominal. Now we work per page 36. Yes, the control is complete. Right. Right now we'll be working with ENPO2. So you need to select the display, and we confirm RDR along the roll axis is here. We confirm and we copy, and we're monitoring that. And the TV system is on, and we're waiting for the first measurement from you. First measurement, 17:04:21.
You've been watching the launch of the Soyuz MS-22 mission from the Baikonur Cosmodrome, carrying NASA astronaut Frank Rubio, as well as Russian cosmonaut Sergei Prokopyev and Dmitry Patelin, on the way to the International Space Station. That was a successful launch from the Baikonur Cosmodrome, setting the stage for their docking at the ISS at 1:11 p.m. Eastern Time, or 17:11 UTC. We're now back live with a full screen here at Kennedy Space Center, showing the Space Launch System out on pad 39B. Latest updates we've heard from NASA Launch Control occurring just during that launch was that the hydrogen flow into the core stage is now in a stop flow condition. So the hydrogen is no longer being flowed into the core stage at this time due to the detection of a hydrogen leak in the tail service mast umbilical unit. This was a major milestone. A key step in today's tanking test was the beginning of loading of liquid hydrogen into the core stage to see if the repairs to a leak that was found back on September 3rd were successful. That leak back on September 3rd resulted in a leak or concentration of hydrogen of around 8% in the tail service mast umbilical area between the two plates, between the flight and ground plates, where that connection is made between the platform, launch platform, and the rocket itself. The safety limit is 4%. There is a leak that's been detected now this morning. We haven't heard yet what the magnitude is of that leak and what the level of concentration of hydrogen is in that area. We're looking live at a bit by view of the bottom of the core stage where the tail service mast umbilical connects to the core stage. That's where the propellants are flowed into the vehicle. We've now heard that the hydrogen concentration detected was at 7%. So that is indeed above the 4% safety limit. countdown clock for today's tanking test has just passed T-minus 4 hours, 48 minutes, and 48 minutes, rather. T-minus 4 hours, 48 minutes, and 46 seconds. A lot of fours there. The clock is continuing to tick down toward the next hold, which is at T-minus 10 minutes. However, the launch team is now troubleshooting this hydrogen leak in the tail service mast umbilical that has cropped up yet again. This view shows the tail service mast umbilical to the left of the rocket. That umbilical has two lines that feed into the core stage. One is flowing liquid oxygen, the oxidizer. One is flowing liquid hydrogen, the fuel. Here you see a view from that tail service mast umbilical looking at those connections. There are umbilical plates that connect to the vehicle with each line, one on the oxygen side, one on the hydrogen side. Those plates, again, connect those lines from the launch platform to the rocket. Here's a view taken from inside the vehicle assembly building last year before the core stage of the Space Launch System was actually stacked on the platform. You can see the two solid rocket boosters here on each side already stacked on the platform in this photo. For reference, you can get a feel for what you're looking at there. The core stage is now in the middle between those two boosters. This view taken last year before stacking of the core stage shows the tail service mast umbilical. You can see that nest of wiring and cables. In this view, you're looking on the left at the liquid hydrogen umbilical lines. On the right is the liquid oxygen umbilical lines. There's an 8-inch fill and drain valve or fill and drain line that flows liquid hydrogen into the core stage from the launch platform, and a quick disconnect fitting where that connection is actually made from the launch platform to the rocket. And during the September 3rd launch attempt back a few weeks ago for Artemis 1, teams detected a hydrogen leak during the loading process during the countdown. And that leak caused hydrogen concentrations in the tail service mast umbilical area to reach about 8%, double the allowable limit of 4%. So far this morning, the team has detected concentrations of about 7%, and NASA reports this signature of the leak today is similar to what they saw a few weeks ago on September the 3rd. So right now, hydrogen is in stop flow, so hydrogen is no longer flowing into the rocket at this time. They're allowing these lines to warm up a bit. And hopefully, NASA hopes that this troubleshooting procedure will stop the leak, or at least reduce the leak down to below that 4% limit. By allowing the lines to warm up, the shape of those seals can change. Again, this hydrogen is chilled down to minus 423 degrees Fahrenheit, so it's extremely cold. And when you subject hardware and seals to those types of temperatures, the seals can become unseated. So NASA is running through this troubleshooting procedure now. This troubleshooting procedure is similar to what they tried back on September the 3rd to try to eliminate that leak. But obviously, the troubleshooting back on the 3rd did not work. And that prompted teams to scrub the countdown and move into repair of the leak by replacing a seal in that 8-inch line that connects between the launch platform, and the rocket. So today, the team is operating with that fresh seal in place, and yet the hydrogen continues to leak as they start the loading process. So we'll stand by for further updates from NASA as the troubleshooting continues this morning. Good morning again. You're looking at a live view of Launch Complex 39B at NASA's Kennedy Space Center in Florida. This up-close view shows the tail service mast umbilical unit, where the hydrogen lines that flow into the core stage are located. The launch team is currently troubleshooting a leak in the liquid hydrogen loading line. A similar signature to the leak that was detected back on the September 3rd launch attempt for the Artemis 1 moon mission. NASA engineers had hoped to learn during this tanking test today that the leak had been resolved, but so far that is not the case. The leak is still present, with a similar signature to the September 3rd leak during the previous Artemis 1 launch attempt. This view shows the tail service mast umbilical in a closer view, closer shot. On the left-hand side is the liquid oxygen connection. On the right is the liquid hydrogen connection, where the leak is located. The persistent leak that has been plaguing the Space Launch System program for the last few months has been in a quick disconnect fitting. That's where the line that flows liquid hydrogen from the ground storage tank actually connects to the line on board the rocket, right at the interface. There were leaks that were detected earlier in the spring during countdown dress rehearsals. And the most significant leak that's been found in this area was back on September the 3rd during the most recent Artemis 1 launch attempt. And the leak is again present today with a concentration detected of 7% hydrogen in that area. That's above the allowable safety limit of 4%. So right now the team is troubleshooting this leak by allowing this connection to warm up. They've stopped the flow of cryogenic liquid hydrogen into the rocket. That brings this connection back to closer to warmer ambient temperatures. And the plan is to resume the flow of liquid hydrogen through this connection, through this line, in hopes that that shock of the cold temperature and the pressure of the hydrogen flow allows that seal to reseat itself. This is a troubleshooting procedure that has been executed several times during this Artemis 1 launch campaign, including on the September 3rd launch attempt, but was not successful in resolving the leak back on September the 3rd. That's when NASA officials decided to stand down from the launch attempt and moved forward with a plan to repair this connection. They replaced a seal in this 8-inch quick disconnect line fitting. And with that fresh seal, the engineers hoped to see today that the leak was gone, but the leak is still present. as we wait for further news on the troubleshooting of this liquid hydrogen leak. Here's a shot from the mobile launch tower looking down on the Space Launch System. For this tanking test, the crew access arm next to the Orion spacecraft is extended to connect up to the side hatch of the Orion capsule and the crew module area. During previous countdown dress rehearsals and the launch attempts, that crew access arm has been retracted during the propellant loading process. The Space Launch System stands about 322 feet or 98 meters tall. And here you can see the Orion spacecraft inside the aerodynamic fairing that protects it during the initial phases of launch with that US flag on it, as well as the NASA meatball logo and the European Space Agency logo down below near the Orion service module on the fairing covering the Orion service module, which comes from Europe, built by Airbus and funded by the European Space Agency. So right now we're waiting on word from NASA's launch control team on the status of the troubleshooting of this hydrogen leak. The troubleshooting steps that have been introduced and are being executed involve letting the quick disconnect fitting warm up to closer to ambient temperatures before resuming the flow of liquid hydrogen through that line in hopes of getting this seal to reseat.
7 minutes past 11 a.m. Eastern Time. This is Artemis Launch Control with an update on the hydrogen leak that was detected inside the Space Launch System core stage. The team recommended and the launch director approved a troubleshooting plan to try and seal a leak on the liquid hydrogen side. It's located, and you're looking at your screen there. You have the tail service mast umbilical, the large gray structure coming up from the zero deck of the mobile launcher, and then to the right of it, the rocket. And those lines that go between them contain in them the liquid hydrogen line as well as the liquid oxygen line. The team has a pre-planned procedure that they go through when they reach a hydrogen leak. This is similar to the one that they did during the second launch attempt on September 3rd. They have allowed the line to warm up. They purged the line, allowed that liquid hydrogen line to warm up, and now they're going to begin flow again through there. The hope is that the warming of the line allows the seal where they believe there's a leak to kind of reseat against the quick disconnect, the 8-inch line that fills the tank with liquid hydrogen. But there's a slight change to this plan that they just got approval from the launch director. A slight change to this plan. It's different from previous plans during the second launch attempt, and that is that they're going to drop the pressure on the storage tank to less than 5% PSI. They're going to drop that. That is very low pressure for this operation. And then as they recover flow into the tank, into the cryosphere, they're going to very slowly and as kind and as gentle as they can step up the pressure for the fill of the hydrogen. So a little bit of different approach here to the warm up and recover fill that they've done previously. They were already taking great care to not thermally shock the system, going very slow with the chill down, going very slow with slow fill, and then even to the transition to fast fill where the pump speeds are running. I'm sorry, there's no pump speed, no pump on the liquid hydrogen side. Rather, they increase the pressure at a very slow rate to allow that liquid hydrogen to flow in. So that's the plan. It's been signed off on, and the liquid hydrogen team is putting it into work right now. You're looking at the area where that liquid hydrogen flows into the rocket, and it's on the other side of that flight plate, that square plate, where the leak was detected. It was a 7% hydrogen leak detected by the sensors in there. And so from there, they're hoping that that reseats the leak. The leak stopped immediately once they stopped flow. So we're standing by. We'll let you know how the flow goes and the recovery. This is Artemis Launch Control.
That was the voice of Daryl Nail, NASA's Launch Control Center commentator, providing an update on the status of today's tanking test out at pad 39B. So the troubleshooting plan that the team is going to try after letting this hydrogen line warm up a bit and purging it with helium will be to drop the pressure in the hydrogen cryosphere or ground storage tank out at pad 39B down to about 5%, which is, according to NASA, a very low pressure, and then gradually ramp up the pressure in that system, in that tank, to begin pushing the hydrogen fuel, these hydrogen molecules, chill down to minus 423 Fahrenheit through the transfer lines up into the launch platform, and then finally through the tail service mast umbilical and this quick disconnect fitting that's been having a persistent leak. This is continuing the quote, kinder, gentler approach to tanking that NASA engineers have talked about in recent days. These are modified procedures. This troubleshooting procedure that they're about to try is different from the troubleshooting the team tried back on the September 3rd launch attempt, in that they're lowering the pressure down to a very low level in that ground storage tank before slowly ramping up the pressure to force and push this hydrogen fuel toward the launch platform and then into the launch vehicle's core stage. Again, hydrogen is a very small molecule, H2, two hydrogen atoms bonded together. And it's also very light, so there are no pumps required to force the propellant into the rocket. For liquid oxygen, which is a heavier molecule, pumps are necessary to load that oxidizer into the vehicle. But for hydrogen, it just involves an increase in pressure to begin pushing that fuel into the rocket. So we'll stand by for word on how this troubleshooting plan plays out over the next few minutes. Again, if you're just joining us, I'm Stephen Clark, reporting live on today's Artemis 1 tanking test occurring at NASA's Kennedy Space Center in Florida. We're continuing to look live at Launch Complex 39B. Here's an up-close view, zoomed in on the bottom of the Space Launch System core stage. You can see some of the vapors venting out of the engine section. This gas comes from the chill down of those engines. Here's a look at the design of the Space Launch System. This graphic was created by Steve Kelly, one of our colleagues here on the Spaceflight Now and Astronomy Now team. I mentioned the rocket stands 322 feet in height. That's about 98 meters. And fully loaded with its 755,000 gallons of liquid propellant, as well as the pre-packed solid propellant on the solid rocket boosters. The vehicle weighs about 5.75 million pounds. And at liftoff, the two solid rocket boosters and the 4 RS-25 engines on the core stage will produce about 8.8 million pounds of thrust. Most of that thrust comes from those two solid rocket boosters. About 80% of it comes from those twin solid boosters on each side of the core stage. We've labeled here the major components of the Space Launch System rocket. From left to right, you can see those RS-25 engines. There are 4 of those. And each of the solid rocket boosters is comprised of 5 segments with steel casings. These segments were cast with the solid propellant at Northrop Grumman's booster fabrication and development facility in northern Utah, and then shipped down to a KSC by train back in 2020. These booster casings are reused from the Space Shuttle program, as are the 4 RS-25 engines. The major, most significant, largest piece of the Space Launch System is the core stage, which contains these giant tanks of liquid hydrogen and liquid oxygen that NASA's launch team is attempting to load this morning at KSC. The core stage was manufactured by Boeing at the Michoud Assembly Facility in New Orleans. That's the same facility that was once used to construct the external tank for the space shuttle.
Okay, the team
And
is in
we're going to listen to Daryl Nail
recovery. They ran
again
that
from
procedure
NASA TV.
and now getting ready to begin liquid hydrogen flow back into the vehicle. Again, getting ready to flow liquid hydrogen again back into the rocket from the tail service mast umbilical that you see on your screen. We're going to get that flow going here momentarily.
So Daryl Nail from NASA TV just gave us an update that the liquid hydrogen flow is set to resume momentarily. Looking again at this graphic of the Artemis 1 moon rocket, this infographic shows the various elements of the vehicle. I mentioned the core stage and the Sol rocket boosters produced by Boeing and Northrop Grumman. The upper stage, or interim cryogenic propulsion stage, was manufactured by United Launch Alliance, and it's derived from the upper stage that flies on ULA's Delta IV Heavy rocket. And then on top of the vehicle is the Orion spacecraft, comprised of the service module produced in Europe and assembled, undergoes final assembly in Germany by Airbus. And then the crew module is manufactured by Lockheed Martin. That's where on future Artemis missions, the 4 astronauts will ride for the journey to and from the moon. And then on top of the vehicle at the very tip of the Space Launch System is the launch abort system. That's the escape rocket that would propel the Orion spacecraft and its crew away from the rocket in the event of an in-flight emergency or a mishap on the pad before liftoff. That launch abort system is powered by motors developed by Northrop Grumman and Aerojet Rocketdyne. For the Artemis 1 uncrewed test flight, the launch abort system does not have an abort motor. So the launch abort system will not be fully active for the Artemis 1 mission. However, it does have the jettison motor, which is a separate motor in that needle-shaped system structure. And that jettison motor is required to push that tower off the top of the Orion spacecraft after launch to allow the Orion to then separate from the Space Launch System later into the flight to begin its trip to the moon. This Artemis 1 test flight is an uncrewed mission, and it's designed to pave the way for future crew flights to the moon. If the Artemis 1 test flight goes well, NASA plans to launch Artemis 2 on the next Space Launch System and Orion spacecraft in the 2024 timeframe. But Artemis 1 has to get off the ground first, and as we're seeing over the last couple of months, that has been a problem with these persistent hydrogen leaks. The first hydrogen leak was detected way back in April during a countdown dress rehearsal. And then there was a hydrogen leak in a different system in a bleed line detected in June during a countdown dress rehearsal. And then the hydrogen leak was detected again on September 3rd in the fill and drain line quick disconnect. It's the same location that the leak was detected back in April, actually. However, that area did not leak during the June countdown dress rehearsal or during the August 29th launch attempt for Artemis 1. It also did not leak, at least to the point where it exceeded the 4% threshold, 4% hydrogen concentration safety limit. There was a small leak detected back on the 29th of August, but the team was able to get around that before finally scrubbing that launch attempt due to a separate issue. And then the leak recurred on September 3rd and was more significant than any of the countdowns that occurred previously. And NASA is seeing a similar leak signature today. See the countdown clock at the Kennedy Space Center press site continues moving, just past to T-minus 3 hours, 47 minutes. This view comes from the KSC press site, more than 3 miles away from Pad 39B. You can see the Space Launch System off in the distance with some of the gaseous oxygen venting from the top of the core stage. Liquid oxygen loading has been continuing throughout this troubleshooting of the hydrogen system and this hydrogen leak. At last update from NASA's launch control team, the troubleshooting plan to begin resume flowing liquid hydrogen into the core stage was about to begin. That was a few minutes ago. This troubleshooting step to allow these lines to warm up and then to purge these lines with helium and then resume flow is designed to hopefully, at least in according to NASA, allow this seal to reseat itself as it again is subjected to these cryogenic conditions and the pressure from the hydrogen flow. As we continue to await an update from NASA Launch Control, we're seeing these continued views from engineering cameras out at Launch Complex 39B. Engineers in the Launch Control Center are operating these cameras, panning them up and down, left to right, showing various parts of the Space Launch System. These cameras are used for inspections of the thermal protection system, or the orange foam insulation that covers much of the skin of the Space Launch System moon rocket. And now here's an up-close vent at one of the vents, up-close view of one of the vents on the rocket. Looks like it could be an gaseous oxygen vent, perhaps. If you're just joining us, we're awaiting an update from NASA's launch control team on the status of troubleshooting of this hydrogen leak that's been detected on the Space Launch System during this tanking test. If you haven't had a chance to do so, please hit the like button on our YouTube stream. This helps us gain a larger following for our coverage. So please don't forget to hit that like button here on our YouTube stream.
Update on the resumption of flow into the core stage. We are now in LH2 fast fill. We are currently now in LH2 fast fill. This after a troubleshooting plan was put into play to try and reseal a leak around an 8-inch hydrogen fuel line that developed after the previous transition from slow fill to fast fill. So again, currently we are now in fast fill on the hydrogen line.
That was Daryl Nail, the NASA launch commentator for today's countdown test at Kennedy Space Center, saying the hydrogen is now in fast fill mode. So the fast fill transition has occurred for the liquid hydrogen system, and the teams are monitoring concentrations from hazardous gas sensors near the tail service mast umbilical to determine if the leak is still present. This view you're seeing now is from a camera on the tail service mast umbilical looking at the core stage, the bottom of the core stage of the Artemis 1 moon rocket. There are two umbilicals here. On the left is the liquid oxygen loading umbilical. On the right is the liquid hydrogen loading umbilical. These are used to fill and drain the core stage of the Space Launch System moon rocket. The connection between this umbilical and the rocket on the right-hand side of your screen here, the hydrogen connection, is where this persistent hydrogen leak has been detected. And with the fast fill of liquid hydrogen resumed, the launch team is monitoring concentrations in that area to determine if there is still a hydrogen leak present. Again, at last report from NASA's Artemis launch team, the liquid hydrogen flow into the core stage had resumed a few minutes ago in fast fill mode. That's the point or transition point at which the team had detected a hydrogen leak earlier this morning. And we haven't heard any updates since on whether the leak is still there or if this troubleshooting by allowing the hydrogen line to warm up and then resuming the flow at lower pressure has indeed worked.
Okay, we get an update on the flow of liquid hydrogen that has resumed into
launch control.
The core stage. After we had a stop flow with a leak, it has resumed in. We are currently at roughly 14% filled on the liquid hydrogen side after getting back into LH2 fill. So there was a discussion between engineers and the launch director about getting data about this pressure-assisted seal that leaked. The moment that it leaked, they're actually currently pretty close to the point of having the same amount of pressure when the leak started, so they're currently watching this very closely. And at this moment, their data is telling them that they're less than a half a percentage point concentration of hydrogen on the leak. So there is a very small leak, less than 4%, which is the constraint. But they are tracking to see if it's following the increase of pressure. SLS chief engineer and others requested that they be able to gather data as they raise the pressure, and they're currently doing that now. They want to gather data to see at what point the leak changes with an increase in pressure. During the first run, they went straight to the roughly 10 psi when they went from slow fill to fast fill, but in this case they're stepping it up very slowly. And so the chief engineer for SLS, John Blevins, and the EGS chief engineer requested and got approval from the launch director to have a contingency plan in place if the leak reaches an more than 10% concentration of hydrogen inside that cavity for more than 5 minutes. They want to see if it goes up to 10% and stays less than 10%, 10% or less, for five minutes. If it reaches that level, they want to be able to gather data on this pressure-assisted seal to see how it's performing. If it goes above 10, they're going to go into stop fill and revert. The launch director says that if they also see a sharp increase, she wants measures immediately put into play to stop the leak. This plan is all in the name of gathering data about this seal, which has been troublesome in a previous launch attempt, if you've been following the Artemis 1 program. It created it caused a scrub back on September 3rd. And so the team really wants to closely watch what's happening as they raise pressure and the flow increases hydrogen into the rocket through that umbilical line that you see there. The tail surface mast umbilicals, the gray protrusion on the left. The lines go into the rocket on the right. And the area with where the leak is right up against the rocket at the plate that connects those umbilicals right there. There's a shot of it to the rocket. Again, they detected a leak at 5 minutes after 10 a.m. Eastern time, and it created a stop flow. This time, they want to maintain a slow flow, track the pressure, track the rate of leak, and then gather the data that results from that. That's currently the contingency plan that's in place and has been approved by the launch director as they raise the pressure to get to a faster rate of fill on the hydrogen side. Currently, we're at 17% full on the hydrogen side, and on the liquid oxygen side, we're at 89%. The goal of today is a cryogenic demonstration test to tank all 4 cryogenic propellant tanks, super chilled propellants, into the rocket to determine if a repair to a seal on the hydrogen line into the core stage is going to hold. They encountered another leak today, but again, they are watching that closely. as they are slowly raising the pressure, which results in more propellant going into the tank at a faster rate. Stand by for more updates. This is Artemis Launch Control.
That was Daryl Nail from the Launch Control Center here at Kennedy Space Center in Florida, providing an update on the troubleshooting for this hydrogen leak in the tail service mast umbilical area. As he mentioned, the liquid hydrogen is now at 17% full on the core stage. Liquid oxygen is now at 89% full. And the team is slowly ramping up pressure in the flow of liquid hydrogen through that tail service mast umbilical connection into the core stage. Here's a view of that connection. The right-hand connection is the liquid hydrogen umbilical. On the left is the liquid oxygen umbilical. And teams are monitoring the concentration of hydrogen near that connection through gas sensors. Right now, that concentration is at about 0.5%, well below the 4% safety threshold to proceed with the tanking operation. But they're ramping up pressure in that flow, and as they did that during the earlier tanking attempt during earlier in the countdown this morning when they attempted to transition into fast fill.
Update on the fill rate. We are currently in the pressure required for fast fill operation. On the liquid hydrogen side, we've currently reached that pressure. And still showing around half a percentage point concentration of hydrogen inside the can where the leak is. Again, we are fully in fast fill on the liquid hydrogen side with just a very small leak being detected in the can.
That was again an update from Daryl Nail from the launch team. He's
correction, not in the can, within the side, the QD cavity where the connection point is, right up against the rocket.
That was Daryl Nail, the commentator from the Launch Control Center from NASA Public Affairs, providing an update on the tanking operation this morning. So indeed, the flow of liquid hydrogen into the core stage has reached the pressure required for what's called as fast fill mode, and the leak appears to have decreased in amplitude. The concentration of hydrogen in that area near the connection against the rocket is now at 0.5%, well below the 4% safety threshold. When they got to this point earlier this morning, during the first loading attempt for liquid hydrogen, that hydrogen concentration was 7%. In this split screen view, you're seeing NASA Space Launch System from two perspectives. On the left is a view from a camera at the East Pad perimeter area at Launch Complex 39B, showing in profile a good view of the tail service mast umbilical connected to the bottom of the core stage. On the right is a view from our pad camera at the KSC press site, looking at pad 39B from a distance of about 3.5 miles. An update on the tanking. The liquid oxygen on the core stage now is at 93% full, and liquid hydrogen on the core stage is at 26%. This graphic provided by NASA shows the current status of propellant loading. Liquid oxygen is at 94% with 184,000 gallons now loaded of the 196,000 gallon capacity, and 153,000 gallons of liquid hydrogen has been loaded into the core stage. So 94% full on liquid oxygen, 29% full on liquid hydrogen on the Space Launch System core stage. These are the largest propellant tanks to be loaded during this tanking test. Later in the day, if everything goes according to plan, the team will load the same mixture of propellants, liquid hydrogen and liquid oxygen, into the upper stage, which has much smaller propellant tanks. You can see the temperatures here as well. The liquid oxygen chilled down to nearly minus 300 degrees Fahrenheit. Liquid hydrogen is even colder at minus 423 Fahrenheit.
Okay, the launch team just updating the launch director on a plan to proceed to the next milestone, which is the Kickstart Bleed, the engine bleed kickstart with the liquid hydrogen. So in order to do this, there are several lines that pull the liquid hydrogen back out of the rocket after it has run through the engines. They want to make sure that they can get this bleed started and going. This is part of conditioning, thermally conditioning the RS-25 engines at the bottom of the rocket, the 4 RS-25s made by Aerojet Rocketdyne on the core stage, which is built by Boeing. There they are, the 4 RS-25 engines. So the Kickstart Bleed was a major milestone that they wanted to get to in this particular cryogenic demonstration test. So they're going to pre-chill a 4-inch and a 6-inch bleed line that comes off of these engines and then vents that or bleeds that liquid hydrogen out of those engines. They need to condition the engines to get them ready to start, and this is a test of that, the initial part of that bleed. It's a pressurized bleed to get it going. They close the vent, the liquid hydrogen vent, the gaseous hydrogen at that point when it's venting out. They close that vent to pressurize it, and then a small amount of liquid hydrogen is then bled through all 4 of those engines. Currently, they're managing a very small leak. Stand by.
That was the voice of Daryl Nail from NASA Public Affairs, who's
so
providing
currently,
updates from the control center.
We're at 35% full on the liquid hydrogen side, and they are monitoring a leak that is less than 1%. So engineers and safety, they're comfortable with that. The margin, the area of concern is when it goes over 4%. However, in order to collect data about this seal, engineers have sought and got approved a contingency procedure to allow the leak percentage to go up to 10% for no more than 5 minutes, after which they would go into stop flow and secure the vehicle and stop proceeding with hydrogen flow into the tank. Again, that's to collect data. Okay. Okay, and I've just heard that the bleed kickstart has now begun. Again, the kickstart bleed running liquid hydrogen now back through the engines and then off the rocket has begun. Over on the liquid oxygen side, they have reached 98%. They have transitioned from fast fill to topping. So they are 99% full on the liquid oxygen side. Okay, we're programming note. If you're watching us on NASA TV, the public channel, we're going to be transitioning back to coverage of the Soyuz mission to the International Space Station. We are going to go into live coverage of the docking, and we will be continuing our coverage, as you can see on the bottom of your screen, on the YouTube channel at youtube.com/NASA-Gov-video. Continue coverage.
Again, that was the voice of Daryl Nail from NASA Public Affairs at the Kennedy Space Center. He's providing updates from the launch team, which is proceeding through today's tanking test after apparently resolving the hydrogen leak that was detected earlier this morning that raised concentrations of hydrogen near the tail service mast umbilical connection to about 7%. That's above the 4% safety threshold. That after some troubleshooting and allowing those lines to warm up and purging those helium lines with helium, and then resuming the flow of hydrogen at lower pressure, has appeared to reduce the magnitude of this leak, which is now has concentrations measured below 1%, which is below the 4% allowable limit. So with that, liquid hydrogen loading is continuing in fast fill mode. Liquid oxygen on the core stage has reached the nearly full point. It is now in topping mode to top off that liquid oxygen tank on the core stage. And as Daryl Nail mentioned, the next step beginning now is the Kickstart Bleed on the 4 RS-25 engines. This allows small amounts of this super cold liquid hydrogen to flow into those engines. This Kickstart Bleed is the next step in the countdown to begin thermally conditioning those engines to bring them down to the proper temperature. And this is a milestone in the countdown that has caused issues before.
Okay, the
there was a
engine
leak
bleed
in one of these
kickstart
bleed lines.
Is going on the LH2 side, the liquid hydrogen side. The leak is tracking with the increase in pressure. The vent valve on the hydrogen tank was closed, increasing the pressure on the tank so that they can get that bleed flowing through there. And so we're up over 1% now on the leak rate. But the engine kickstart bleed is continuing nominally.
This engine kickstart bleed has caused issues during previous Artemis 1 countdowns. Back in June, there was a leak in one of these bleed lines that forced the team to bypass that line and continue the tanking, that dress rehearsal without thermally conditioning the engines. That leak, NASA believes, was repaired when the rocket returned to the vehicle assembly building earlier this summer. And then on August 29th, the first real launch attempt for the Artemis 1 mission, data from a sensor showed that one of the 4 RS-25 engines, engine number 3, was not reaching the required temperature during the engine bleed and chill down process. But engineers, after further evaluation, determined that that data was from a bad sensor, and they're using other means to measure the temperature in that engine to verify that it does indeed reach the proper cryogenic condition for a safe ignition and a safe startup. The engines will not be lit during this tanking test, but this test is designed to mimic much of the countdown that the rocket will undergo during a real launch attempt. So they want to demonstrate that this kickstart bleed is working and that all 4 engines do reach the proper cryogenic temperature. And that's the step that's currently underway, this engine kickstart bleed.
Just a few minutes to go On the engine, kickstart bleed on the LH2 side. Just about to reach the max pressure on the kickstart. Leak is up over 3%. It topped out at 3.4%. It's tracking with increase in pressure. But the kickstart bleed is now at the point where the valves are cycling the pressure, meaning it's got it at right about the right pressure for this particular engine kickstart bleed.
That was Daryl Nail from NASA Public Affairs saying that the hydrogen concentration measurements are now or have reached above 3% as the pressure increases. This pressure increase is associated with the start of this engine kickstart bleed. And during that process, there is expected to be an increase in pressure, and that is causing a bit more of a leak in that tail service mast umbilical area. It reached a point above 3%. The allowable limit to continue with tanking during a regular launch countdown would be 4%. However, the launch team has issued approval for them to allow the hydrogen concentration to reach as high as 10% for as long as 5 minutes. If it does indeed reach that point, that would be to gather data on the nature of the leak for additional later troubleshooting and repair potentially down the line.
Okay, the kickstart engine bleed is now complete. Again, the kickstart engine bleed for the liquid hydrogen side is now complete. And so the team transitions to the vented bleed at this point and starts filling the rest of the tank. So the pressure now drops a bit and they continue filling the tank. Again, kickstart bleed is complete and they're moving to continue filling the tank. Vent line is now back open.
Once again, that was Daryl Nail from NASA Public Affairs providing commentary on the progress of today's Artemis 1 tanking test. The engine kickstart bleed procedure is complete and now is transitioning to what's known as a vented bleed. And loading of liquid hydrogen continues on the core stage at this time. With that kickstart complete, the pressure is dropping on the system. This view shows the tail service mast umbilical on the left-hand side of the core stage. That's where the propellants are flowing into the core stage through the launch platform, through lines routed from ground storage spheres out at pad 39B. Here you can see an update on the status of propellant loading. The core stage liquid oxygen is now at 100% full. So all 196,000 gallons of oxidizer have been loaded onto the core stage. Liquid hydrogen has passed the halfway full mark, now at 52%. As propellant loading continues on the Space Launch System core stage, we're seeing continued views from NASA's engineering cameras out at pad 39B, showing close-up views of various elements of the rocket. Here you see one of the connection points between the solid rocket booster and the core stage. We're looking now at the engine section of the Space Launch System core stage. And the other solid rocket booster and the connection joint there, or the bottom of the booster and the bottom of the core stage.
12:42 p.m. Eastern Time. You're looking at a live picture of the SLS rocket on launch pad 39B. I'm Daryl Nail with NASA Communications. We have an update now. The launch team discussing where to go from here. As you can see on your screen, we've been tracking the progress of tanking the core stage of the SLS rocket. It has two tanks, a liquid oxygen and a liquid hydrogen tank. They have completed tanking the liquid oxygen side, as you can see. It's at 100%, and they are currently in replenish. Over on the liquid hydrogen side, it's been a little bit of a bumpy road this morning. Currently at 67% full, but they've been managing a leak at an 8-inch quick disconnect line that feeds right there into the rocket. In between two plates that disconnect when T0 arrives and the rocket lifts off, those umbilicals pull away, and there's a cavity in there where that connection point is. That is where the leak was detected around this 8-inch QD line, which also had a leak and was repaired after a scrub attempt on September 3rd. The team discussing with the launch director the plan to go forward from here, and here's where they settled. They want to gradually increase the storage tank pressure, which will increase the pressure on this quick disconnect as well. It also increases the flow, getting it hopefully to the fast fill flow that would be nominal for a launch attempt. So that's the ultimate goal. She has signed off, Charlie Blackwell-Thompson, launch director here, has signed off on a plan to slowly step up and increase the storage tank pressure, which will increase the flow through that line right there. And as that flow increases, they want to keep track, I should say, of the leak at that QD interface. Right now, it has been tracking well with increases and decreases in pressure. They have been able to manage it quite well. It reached a maximum of 3.5% when they did the Kickstart Bleed, which raised the pressure on the tank as they vented liquid hydrogen through the engines to pre-chill them for what would be a startup of those engines. This is something that they're testing today and a test objective with this cryogenic demonstration. They flowed that through there, and then they ended the Kickstart Bleed, and now they're on a vented bleed. The conversation about whether to go forward after they reach replenish on the hydrogen side came to an agreement between the launch director and her launch team to go ahead and stop at replenish and then discuss whether they want to take the next step, which would be to move forward with a pre-press test. This is yet another test objective for the demonstration today, and that's the pressurization of the tank to get a high flow bleed going, which puts it in the condition to start up. They're going to pause at that point once they reach replenish and decide whether or not to move forward. But right now they want to see how this leak tracks with an increase in pressure at the storage tank. So that's where we're at right now. Launch team is in agreement. They want, launch director wants the liquid hydrogen team to keep a close eye on this leak, as they have been. And if it gets to a point where it goes over 4% for more than 5 minutes, the team has been advised to stop flowing propellant through that line. So again, to summarize, the liquid hydrogen team is gradually increasing pressure on the fill rate going into the liquid hydrogen tank, which is currently at 70%. They are tracking now the leak rate as well. And the plan is to keep going as long as that leak holds at a steady rate all the way up to replenish, which is at the 99%, 100% mark once they've got it completely full. And then the fill rate goes into a mode where it only replaces the amount of hydrogen that is lost from the natural boil off of propellant inside the tank. As it vents out, they will only replace what is lost. That is the definition of the replenish. So get it up to 100% and then get it into replenish, and then have further discussions about where to go next. We started this cryogenic operation at 7:30 a.m. Eastern Time this morning with a go for cryogenic tanking. The liquid oxygen side proceeded nominally, which in engineering speak is as good as you can expect it. Not so again on the hydrogen side. They encountered a leak. They stop flowed, warmed it up, reinitiated flow, and then noticed that they're able to manage a leak on where they believe the quick disconnect of an 8-inch fill line goes into the seal at the fill plate right there on the rocket. And that's our update for now. This is Artemis Launch Control.
That was again the voice of Daryl Nail, NASA TV's launch commentator from the Kennedy Space Center. He's providing updates based on information he's receiving directly from the launch team at KSC. He said the team is looking at increasing pressure in the hydrogen flow to ramp up the flow rate into the core stage up to what would be a nominal fast fill mode, as they would use during a real launch countdown. There's some confusion and some uncertainty there because earlier in the morning he mentioned that the flow rate had indeed
One more
reached
quick
that
note I
fast
want to
fill
add.
milestone. There's Daryl Nail again.
The launch team is currently on hold for the loading of the upper stage. Again, preparations to load the upper stage of the rocket, the interim cryogenic propulsion stage, which is above the line where you see the top of the booster there, and there's a good shot of it. The ICPS where the inner tank shrinks down, the upper stage of the rocket, which will give that big push to the moon. The plan today is to tank that, but at the moment, that is on hold.
That was again the voice of Daryl Nail from Launch Control at Kennedy Space Center, mentioning that the tanking or cryogenic loading of the upper stage of the Space Launch System was currently on hold. That was part of the plan going into today's tanking test, but of course the loading of liquid hydrogen onto the core stage is now running behind schedule due to this leak that was detected during the initial phase of loading. The team is now managing that leak by modulating the flow rate of liquid hydrogen into the core stage. The team is now discussing increasing the pressure and increasing the flow rate into the core stage to see how that leak responds. They want to get up to the pressure and flow rate that they would nominally use during a real launch countdown in what's known as fast fill mode. Earlier, NASA reported that the flow rate was already at the fast fill rate. However, the latest update from Daryl Nail and Launch Control indicates that appears not to be the case. So a little bit of confusion there from the information we're getting from NASA. However, what is clear is tanking of liquid oxygen on the core stage is complete. That tank is fully loaded. The liquid hydrogen tank continues to be loaded this morning, and the flow rate is being monitored closely to make sure that the leak remains below that 4% allowable limit. But the latest update from NASA is they may increase that flow rate now to get to the point that they would get to the rate at which they would flow liquid hydrogen into the core stage during a real countdown, and they'll measure how that leak responds to that change. This is all part of a process of gathering data on the leak for NASA decision makers to decide the next step in the Artemis 1 launch campaign and to determine whether the rocket is ready to continue with preparations for a launch attempt as soon as next week, or if that may have to be delayed some number of days. The current launch period closes on October the 4th. So NASA has until October the 4th in this launch period, which opened actually on the 19th of September, 2 days ago. So the current launch period extends from September 19th till October the 4th. And the earliest possible launch opportunity that was penciled in on the schedule, if today's tanking test went well, and also pending a decision from the range on a certification extension for the flight termination system batteries, was no earlier than September the 27th. Again, that assumes those two big question marks were resolved to the satisfaction of NASA's management team. But there has been a recurrence of this leak this morning in the tail service mast umbilical. And after some troubleshooting, that leak diminished to below the safety limit, below the allowable limit of 4% concentration of hydrogen in that tail service mast umbilical connection. And at last report, that leak remains below that 4% limit, which would, in theory, if today was a real launch attempt, would be within the launch commit criteria for the countdown during a real launch attempt. But there still is a leak in that tail service mast umbilical. And engineers are eager to gather more data to try to determine what may be causing that leak before deciding how to proceed with the next steps in this launch campaign for the Artemis 1 lunar test flight. This split screen shows two views of the Space Launch System moon rocket, and on pad 39B on the left hand side is a view from a NASA camera on the eastern perimeter of the launch pad looking west, zoomed in on the base of the core stage in this tail service mast umbilical that we've talked so much about. On the right is a view from the Kennedy Space Center press site from one of our Spaceflight Now cameras.
5 minutes past 1 p.m. Eastern Time here at the Kennedy Space Center in Florida. It's a pretty nice day outside. We are currently in hour 5, or hour 6, I should say. We're 5.5 hours into the cryogenic demonstration test for Artemis 1. You're looking at the bottom of the Space Launch System rocket, its 2 boosters, and core stage. The test objectives today were to tank this rocket. It has 4 cryogenic propellant tanks, 2 oxygen, 2 liquid hydrogen. The ones inside that core stage, though, the bottom part of it, are massive, largest in the world for a rocket booster. And so those started at 7:30 a.m. this morning with liquid oxygen. That currently is 100% full. And over on the core stage liquid hydrogen side, we're at 95% filled. There are the stats that we track with our real-time graphics. We encountered an issue right around 10 a.m. this morning with the liquid hydrogen loading. There was a leak detected, and that resulted in a stop flow of the loading on the liquid hydrogen side. It was a pretty significant leak at the time. Engineers then talked it over, went to their pre-planned procedure with a small twist, and that was to lower the pressure on the storage vessel for the liquid hydrogen and then ease back into it after they allowed the quick disconnect line, which is right through there on those umbilicals. Those umbilicals feed the fuel lines right into the rocket. That's where the leak was detected. It went to 7% concentration of hydrogen, and that created a stop flow. They allowed that line to warm up after they purged it out, and then they reinitiated the fill. They resumed the fill into the rocket, and at that point, ever since then, and engineers don't exactly know why, but it has been a manageable leak, reaching only a maximum percentage of 3.4% as they raised the pressure back up to resume fill. And that's where we stand. Engineers are wanting to understand more about how this seal is acting under pressure. And so far, ever since that they resumed fill, they haven't had a substantial problem. The leak is still there, but they are still moving forward with tanking the rocket, and we're just a couple percentage points off from having the entire core stage completely tanked. Now, as far as the upper stage is concerned, that's on hold at the moment. The plan was to tank both of its cryogenic propulsion tanks, both of them liquid oxygen and hydrogen as well, but much smaller tanks. That's on hold at the moment while engineers decide after they get to replenish, which is when we hit the 100% mark, there's going to be a conversation about what to do next, what steps to take, how they want to proceed, what data they've been able to gather about this seal as it tracks with the increase and decrease in pressure. Once they fill this rocket, they do have to detank it, and so that is a consideration as well. The next milestone beyond replenish would be to pre-press the tank. And this would bring the tank to flight pressures, increasing the pressure both inside the tank and on that QD where the leak is. And so engineers plan to talk about the data that they've gathered through the course of this tanking and to decide a path forward. But at the moment, the upper stage is currently on hold. The tanking of the upper stage currently on hold. And this is Artemis Launch Control. Quick update for you. We just reached replenish on the hydrogen tank in the core stage. Again, we just reached replenish on the core stage hydrogen tank. So this means fast fill is complete. I'm listening to the team now. Fast fill is complete, and they've gone into replenish, which this is a mode where the valves are only opened enough to fill what is lost from boil off inside the tank, the boil off of the minus 423 degree liquid hydrogen. But some interesting data to pass along that we just learned, and that is that during the fast fill operation, where the storage tank was at full pressure for loading the liquid hydrogen, the leak rate was less than 0.5%. So right around 0.5% leak rate, which is very manageable for the team here, but also at the moment leaving a lot of folks scratching their heads on this one. But they're going to have some conversations on this particular seal and how it's been behaving up until this point, and discuss a path forward now that we are in replenish. This is Artemis Launch Control.
You've been hearing some additional updates in the last few minutes from Daryl Nail, who is from NASA Public Affairs at Kennedy Space Center, providing updates from the Artemis Launch Control Team. The liquid hydrogen tank on the core stage of the Space Launch System moon rocket is now in replenish mode, so the core stage has been fully loaded with its supply of 733,000 gallons of cryogenic propellants today. That is primarily comprised of liquid hydrogen. $537,000 gallons approximately of liquid hydrogen were loaded, and 196,000 gallons of liquid oxygen.
Welcome back to the Kennedy Space Center. For those watching on NASA's public television channel, we're at the Kennedy Space Center here in Florida, where we are currently in the Artemis 1 cryogenic demonstration test for tanking. Quick update, preparations are being made to tank the upper stage of the rocket after the core stage reached replenish. Engineers discussing next steps now. Please stand by.
That was Daryl Nail again from NASA Public Affairs. Earlier, he reported the leak rate for hydrogen during the fast fill loading on the core stage appeared to stabilize around 0.5%. That's well below the 4% acceptable threshold for hydrogen concentrations around the tail service mast umbilical.
This is Artemis Launch Control here at Launch Complex 39B. You're looking live at the Space Launch System rocket. Stand by. Okay, we're getting some good news from the liquid hydrogen team in regards to the leak that they were looking at early on in this operation and loading the core stage. And that is the leak reversed its trend where previously when pressure increased, the leak increased. But now they are seeing a trend for this particular seal that when pressure increases, the leak decreases. This is, as engineers say, the way that it's designed and intended to work so that it conforms to the area that is sealing that quick disconnect connection point for the liquid hydrogen line. And so now both tanks in the core stage are in replenish and are stable. Next up is loading the upper stage of the rocket, and right now teams are conditioning the areas around the engine to prepare them for loading liquid oxygen and hydrogen. And the team's discussing a plan with the launch director just moments ago on one of the main test objectives, which is to do a pre-press test on the liquid hydrogen tank in the core stage after they get the upper stage into replenish. And this will put a fair amount of pressure on that connection right there that you see there, which is the umbilicals. They contain the LH2 8-inch line that we've been talking about, but is now sealing pretty well. The pre-press test is a test where they pressurize the core stage tank by closing the vent, which prevents the boil-off gas from escaping, and then more pressure is added with helium to get to the tank to flight pressure for engine start. This is an important moment to reach. You have to have those engines conditioned at the right temperature in order to start them up, those RS-25 engines, which are just below this point right here. And then once they get it to that point, there's a control loop that cyclically pressurizes the tank, opening the vent valve, which then controls the temperature around those engines, saturating those engines with liquid hydrogen so that they are at the right temperature to start them up and launch. Of course, today is a test. It's a cryogenic demonstration test to show both that the leak has been repaired from the previous launch scrub and to go through some test objectives which haven't been met in previous launch attempts or wet dress rehearsals. And so the team is proceeding forward. Once this pre-press test is completed, they won't have to do it again. Once validated, the launch team will be able to adjust the pressure during the high-flow liquid hydrogen engine bleed inside of terminal count. That's the final 10 minutes of count. And that's when it's critical to have those RS-25 engines that you see right there at the bottom in the center, 4 of them, to be the right temperature for launch. So the situation taking a very positive turn here today as the launch team is pushing forward with loading the upper stage and moving to the next milestone, which is the pre-press test. Those RS-25 engines that you're looking at right there, they are known as staged combustion cycle engines. They burn liquid hydrogen and liquid oxygen propellants at a very high pressure. At full throttle, the 4 engines will give SLS about 2 million of its 8.8 million pounds of maximum thrust. Those SLS engines start in a staggered fashion. First engine 1, then engine 3, then engine 4, and then engine 2. And they start up approximately 6 seconds before booster ignition. And during ascent, those engines can gimbal or pivoted to direct the thrust and steer the rocket. To learn more about the Artemis 1 mission and the SLS, and go to our website at nasa.gov/Artemis. Again, the website is nasa.gov/Artemis. This is Artemis Launch Control.
To recap where NASA's Artemis launch team currently is in the tanking test today, the cryogenic tanks on the core stage are now both fully loaded. Liquid hydrogen and liquid oxygen have been fully loaded onto the core stage at this time. And preparations are getting underway to start loading cryogenics onto the interim cryogenic propulsion stage. This is the upper stage known by the acronym ICPS. About 22,000 gallons of liquid hydrogen and liquid oxygen will be flowed into the upper stage to continue this tanking test today. Daryl Nail, the NASA launch commentator, relaying updates from the control team at Kennedy Space Center, said the leak rate appears to now match expectations. Engineers would normally expect that the hydrogen leak rate would decrease as pressure in the hydrogen line increases. Sort of an inverse relationship there is what engineers would normally expect. But previously, as teams were troubleshooting this leak, they found that the hydrogen leak rate actually increased as the pressure increased in that line. But now the behavior seems to be more closely matching expectations of what normally should occur. So with that bit of favorable news, the tanking test is going to progress into the next phase today with the loading of cryogenics onto the upper stage of the Space Launch System. Here's a view from our camera at the Kennedy Space Center press site, looking at the Space Launch System 3.5 miles in the distance out on pad 39B. Another remaining milestone today is known as the pre-pressurization test on the core stage hydrogen tank. This will involve closing the vents on the hydrogen tank, allowing pressure to begin to build up in that tank. And then the team will add helium pressurant into the tank to ramp up the pressure even more to start the trend up toward flight pressure, the pressure that the tank would be at liftoff. And NASA says that will induce further pressure and stress on that 8-inch hydrogen line that's been shown to be leaking with currently within limits. However, earlier this morning, it was outside of the 4% allowable limit. And NASA engineers will monitor all that data as the pre-pressurization test gets underway. That's still to come in today's tanking test. If you're just joining us, I'm Stephen Clark from Spaceflight Now, reporting on the status of today's Artemis 1 tanking test at Kennedy Space Center in Florida. If you haven't hit the like button yet on our YouTube stream, please do that now. It really helps us gain a larger audience and a bigger following for our coverage of today's activity here on Florida's Space Coast. So please hit that like button on YouTube. Also, if you haven't done so, please subscribe to our YouTube channel. You'll get alerts when we're going live with live streaming for launches here in Florida, as well as activities like today, this tanking test for the Artemis 1 test flight to the moon. You can support our coverage by becoming a member of our YouTube channel. We have different membership tiers available for you to choose from. If you, depending on which level you choose, you can gain access to exclusive bonus video features that we have available to members only. And again, your contribution through our membership program will help us continue and expand our coverage. We bring you every launch live on our YouTube channel from Cape Canaveral Space Force Station and Kennedy Space Center, as well as activities like today's tests out at Pad 39B. And we also cover launches and spaceflight activity around the country and around the world on our homepage at spaceflightnow.com. And again, your contribution, if you become a member, will help us continue to do and to bring you that coverage as we've been doing for now 23 years since the spaceflightnow.com website went live in 1999. So right now we're waiting on an update on the start of cryogenic tanking of the upper stage of the Space Launch System at Launch Complex 39B.
The launch team just gave the go for loading the upper stage with liquid oxygen and liquid hydrogen. Again, they just gave the go to load the upper stage with liquid hydrogen and liquid oxygen. This comes just after completion of the purge sequence, where they purge out any contaminants from the RL-10 engine. That's the engine of the ICPS, the upper stage that's contained towards the top of the rocket. That's going to be responsible for pushing Orion into its destination, the translunar injection towards the moon.
That was Daryl Nail speaking from Kennedy Space Center and the Launch Control Center. So the launch team is now go for loading liquid hydrogen fuel and liquid oxygen, the oxidizer, onto the ICPS. That's the interim cryogenic propulsion stage, also known as the ICPS, manufactured by United Launch Alliance. This upper stage is derived from the upper stage that flies on ULA's Delta IV Heavy rocket. It's powered by a single Aerojet Rocketdyne RL-10 B2 engine. Again, a very similar upper stage with some modifications from the Delta IV Heavy upper stage flown by ULA. This upper stage, or ICPS, on the Artemis 1 test flight will be used to power the Orion spacecraft on the translunar injection trajectory a couple of hours after launch. So this ICPS will burn its engine 2 times on the Artemis 1 mission, first to reach a stable low Earth orbit after separating from the core stage, which will do most of the lifting to place the upper stage and the Orion spacecraft in a preliminary orbit, but that orbit will not be stable. It will have a low point or perigee that still dips into the upper atmosphere, which would not allow the spacecraft to complete a full lap around the Earth. So a burn by the ICPS engine is required to reach a stable orbit, and then a second burn by the RL-10 engine on this upper stage would be used to complete the translunar injection maneuver. This burn, known as the TLI burn, will send the Orion spacecraft on its way to the moon.
The LH2 main propulsion system chill down is in work. The LH2 main propulsion system in the upper stage is now in work.
That was an update again from Daryl Nail at Launch Control Center, saying that liquid hydrogen chill down on the upper stage engine is now in work. This is a precursor step before the loading of cryogenic propellants onto that upper stage. Per the timeline, this chill down step should occur roughly 20 minutes or so before the actual fast fill of hydrogen into that upper stage.
You're looking live at the Space Launch System rocket here at the Kennedy Space Center in Florida at Launch Complex 39B. Atop is the Orion Spacecraft. We are currently in the midst of the Artemis 1 cryogenic demonstration test, and so far, so good. We've got the first stage completely tanked and in replenish. It's in a stable mode. That was a good operation and some good engineering that we observed as they tanked this rocket. The liquid hydrogen was tanked completely without any issue. The liquid hydrogen showed a leak, but then that leak managed to get to a point where engineers were able to manage it a lot better. It's reduced now. It's reversed its trend of increasing when pressure increases. And so now that leak is something that they have behind them at the moment. And so now they're proceeding on with the chilling down of the main propulsion systems in the upper stage. And we just got a note that the liquid oxygen is now in fast fill for the interim cryogenic propulsion stage. That's the upper stage of the rocket that you see right there. The venting that you see is the liquid oxygen that vents out from the top of the tank there from the core stage. That's normal. With liquid oxygen in replenish, the boiling of the tank below must vent off the super cold gaseous oxygen, and so that's what's happening there. And as soon as that super chilled gaseous oxygen reaches the atmosphere, it condenses the water vapor in the air, and that's how you have that plume there. So the plan is, once the upper stage is tanked and in replenish mode, the launch team wants to proceed on with an important milestone called the pre-press test. Stand by.
That's an update from Daryl Nail from Launch Control. He may come back momentarily with further words on the status of this tanking test, but he mentioned that liquid oxygen is now flowing into the interim cryogenic propulsion stage, or upper stage, of the Artemis 1 moon rocket out at pad 39B. So tanking of the upper stage is now underway after completing core stage tanking on the Artemis 1 moon rocket. Again, the troubleshooting of the hydrogen leak in the tail service mast umbilical appears to have been at least somewhat successful, getting that leak down to a manageable rate within limits, allowing this tanking test to proceed. The total propellant capacity for the Space Launch System is 755,000 gallons. So we've seen 733,000 gallons of propellants, liquid hydrogen, liquid oxygen already loaded into the core stage today. And then 22,000 gallons of propellants will be loaded into the upper stage. And that 5,000 gallons of liquid oxygen is currently being loaded into the upper stage. We're awaiting confirmation of the start of hydrogen loading on the upper stage. So here you see the breakdown. By far, the largest tanks are on the core stage.
A quick update from the launch team.
Here's Daryl Nail again.
The team reporting that they lost boot containment on the ICPS LH2 QD boot. That's the interim cryogenic propulsion stage, the upper stage. Quick disconnect that feeds the liquid hydrogen into the upper stage vehicle. This is something they've seen before. They went straight to their pre-plan. They're working that now. Not going to discuss this on the anomaly net. It's something that they expected, they've seen before, and they've got a pre-plan that they're going to work to get containment. Again, lost boot containment, which is the air that's contained inside the boot where that hydrogen quick disconnect goes into the ICPS. They got a pre-plan and they're working that. Otherwise, as the upper stage loading continues, the plan is once the upper stage is in replenish mode, they're going to proceed forward with a pre-press test of the core stage. That pre-press test is pressurizing the tank by closing the vent on the liquid hydrogen side to prevent the boil-off gas from escaping. And then they're going to get the engines into a high flow bleed. And that high flow bleed is important because it's triggered inside of terminal count when it's critical for the RS-25 engines to be the right temperature for launch. So that pre-press test is still ahead of the team, something they're looking forward to. It's a big milestone here and one of the main test objectives of the day. The SLS rocket will launch an uncrewed Orion spacecraft from Launch Complex 39B if this test is successful. Launch Complex 39B, of course, is NASA's modernized spaceport at Kennedy. Once this rocket does launch, the Orion spacecraft will be sent into orbit around the Earth. It will deploy its solar arrays, and then the upper stage that we're fueling right now, the interim cryogenic propulsion stage, will give the Orion spacecraft at the top of the rocket the big push called a translunar injection needed to leave Earth's orbit and travel towards the moon. The stats on the ICPS, on the LH2 side, it carries 10,000 pounds of liquid hydrogen. On the liquid oxygen, it's 53,000 pounds. Much smaller tanks than the core stage. If you'd like to learn more about the ICPS and the Artemis mission, go to our website at nasa.gov/Artemis. You see it on your screen there, nasa.gov/Artemis. This is Artemis Launch Control. We are currently in fast fill for liquid hydrogen and liquid oxygen on the upper stage of the Space Launch System rocket. Again, we are currently in fast fill for both tanks in the upper stage of the rocket. Good looking shot right there, looking down on the rocket. The ICPS is connected to the Orion spacecraft right there at the top of the rocket. And the propellant that's flowing through the umbilical lines right now is flowing at fast fill. This is Artemis Launch Control.
You've been listening to the voice of Daryl Nail, relaying updates from the Artemis 1 control team at Kennedy Space Center in Florida. NASA's launch team is now in fast fill mode on both liquid oxygen and liquid hydrogen on the upper stage of the Space Launch System. So 17,000 gallons of liquid hydrogen and 22,000 gallons, rather 17,000 gallons of liquid hydrogen, 5,000 gallons of liquid oxygen currently being loaded onto the upper stage. With the tanking test progressing today, here's a look at the launch opportunities ahead for the Artemis 1 mission. Going into this tanking test, NASA officials were saying that the earliest launch attempt for Artemis 1, next launch attempt for Artemis 1 would be September the 27th. That's next Tuesday. But of course, engineers and managers will evaluate the results of today's tanking test before deciding whether and when to proceed into an actual countdown and launch attempt. This would be launch attempt number 3 for Artemis 1 after 2 scrubs back on August the 29th and September the 3rd. So here are the times of the current launch period, known as launch period number 26, which opened 2 days ago on the 19th of September and extends until October the 4th. Right now, NASA has penciled in launch opportunities for the 27th of September, which would have a 70-minute launch window opening at 11:37 a.m. Eastern Time. That's 15:37 UTC, followed by a potential backup opportunity on October the 2nd at 2:52 p.m. Eastern Time. That's 18:52 UTC. There are other dates available for NASA during the remainder of this launch period. However, some of those dates come with some constraints. For example, ULA, which built the upper stage, has 2 launches planned in the coming days. One of them is scheduled for September the 24th, this Saturday. That'll be a Delta IV Heavy mission from the West Coast out at Vandenberg Space Force Base in California, which uses an upper stage very similar to the upper stage on the SLS moon rocket. And engineers will want to review data from that Delta IV flight before proceeding into the SLS launch to make sure there are no issues encountered during that Delta IV mission. There's also a launch on the Eastern Range at Cape Canaveral of an Atlas V rocket on September the 30th. And the Atlas V uses a different design for the upper stage, but it's still powered by a similar RL-10 engine. So engineers from Aerojet Rocketdyne and ULA will want to evaluate the performance of those missions and those upper stages potentially after those launches before proceeding into a launch attempt for Artemis 1. There's also a crew mission on the range. A SpaceX Falcon 9 rocket is set to launch no earlier than October the 3rd from Launch Complex 39A at Kennedy Space Center. NASA officials have said they're evaluating that schedule and the schedule for the Artemis 1 launch campaign. And the launch campaign for the next crew mission, known as Crew 5, and the Artemis 1 mission right now are proceeding in parallel. But if the Artemis 1 launch is going to be scheduled for early October, the Crew 5 mission could be delayed by a few days to allow that Artemis 1 mission to proceed with another launch attempt. There are constraints on launch activities and launch operations going on at neighboring pads. These two launch pads, 39A and 39B, are about 1.7 miles apart. That's about 2.7 kilometers. And during an SLS launch attempt, pad 39A has to be cleared and evacuated for safety reasons. And there are also limits on what can be done at pad 39B during a Falcon 9 launch from pad 39A. So lots of schedule uncertainties and issues that need to be worked around during this Artemis 1 campaign over the coming couple of weeks, with a lot of launch activity for ULA and SpaceX that have to be taken into account. The launch period closes on October the 4th, as I mentioned. That's when the position of the moon in its orbit around the Earth moves out of the location where the flight to the moon would be possible for the Orion spacecraft. The launch periods cycle between roughly 2 weeks of launch opportunities, followed by around 2 weeks of unavailability due to the position of the moon in its orbit. There are also other constraints that have that NASA officials have to take into account just based on the physics and trajectory and orbital dynamics of the mission. They want to make sure that the splashdown of the Orion spacecraft in the Pacific Ocean at the end of the mission occurs in daylight. That's one of the other constraints they have to consider. It limits their launch availability. And also the team wants to ensure that the Orion spacecraft's solar panels spend no more than 90 minutes in shadow. They want to keep solar illumination on those solar panels as much as possible to maintain a good battery charge on the spacecraft throughout the mission, which will send the Orion into orbit around the moon and then bring the spacecraft back to Earth again for the splashdown in the Pacific Ocean. After October the 4th, the next launch window, next launch period, known as launch period 27, opens on October the 17th. And here are the launch times for that next launch period, which runs about 2 weeks from the 17th of October until the 31st of October, Halloween. So if the mission does not get off the ground in this next or ongoing launch period, the next launch period would be in the second half of October, and here are the launch times available then. If for some reason the Space Launch System has to be rolled back to the vehicle assembly building for any repairs or further troubleshooting, or in the event that the Eastern Range, the Space Force Range Safety Team, does not approve an extension to the certification of the Space Launch System's flight termination batteries. This is part of the Range Safety Destruct system. Then the rocket would have to potentially be rolled back to the VAB for retesting of that flight termination system and a recertification of the batteries. That would preclude a launch during the current launch period that extends to October the 4th and would push the Artemis 1 launch at least until this next launch period in late October, and potentially into the following launch period 28, which opens on November the 12th. We don't have launch times available yet for the entirety of launch period 28, but we do know that launch period would open November the 12th and run for a couple of weeks. But NASA officials certainly hope to get this mission off the ground in the current launch period before October the 4th, with a tentative launch opportunities penciled in for September the 27th, which is just 6 days away, followed by a potential backup on October 2nd. Again, you're looking now live at a view of the Space Launch System moon rocket on pad 39B. This camera is zoomed in a bit on the top of the core stage. And then the launch vehicle stage adapter is that conical section covered in the orange foam insulation that tapers down to the smaller diameter of the upper stage and the Orion spacecraft. Near the top of this view, you can see the aeroshell panels that surround the service module of the Orion spacecraft, with the blue NASA meatball logo visible there. And then below that is the Orion stage adapter with those two black and white checkered marks. And then that white section just below that leads down to the launch vehicle stage adapter, where that orange and white interface is the interim cryogenic propulsion stage. That's the upper stage that's currently being loaded with propellants, with its RL-10 engine encapsulated basically inside that launch vehicle stage adapter. That's where the engine bell is located for the upper stage. Again, about 22,000 gallons of cryogenics currently are being loaded onto the ICPS upper stage at this time. This upper stage was manufactured by United Launch Alliance at its factory in Decatur, Alabama, and is based on ULA's Delta IV Heavy upper stage. The loading timeline during this tanking test is running about 2 to 3 hours behind schedule at this point due to this hydrogen leak that was found at the very beginning of the hydrogen loading process on the core stage. But the troubleshooting of that leak appears to have been at least somewhat successful. NASA says that leak is now manageable and is within the allowable safety constraints to proceed with this tanking test. Cycling through some camera views. These camera views come from engineering cameras out at Launch Complex 39B, showing various views of the giant 322-foot tall, 98-meter tall moon rocket for NASA's Artemis program. This is the vehicle that NASA plans to use to send astronauts to the moon, beginning with the Artemis 2 mission, scheduled roughly 2 years from now, which will be the second flight of the Artemis, or the Space Launch System moon rocket, and the next flight of the Orion spacecraft. This Artemis 1 mission is a precursor to that, a demonstration flight to basically test out various systems on the rocket and the Orion spacecraft, put them through their paces, essentially a shakedown cruise before committing to a crew flight around the moon on Artemis 2. This view of the Space Launch System comes from a camera near the top of the mobile launcher tower that's looking down on the Orion spacecraft with the crew access arm extended next to the hatch. And further down the vehicle, you can see the ICPS, or upper stage, that's currently being loaded with cryogenics. And below that, the core stage itself and the two solid rocket boosters.
Quick update on
Here's Daryl
the
Nail again with an
cryoloading for
update
the
from
upper
Launch Control.
stage. We are still in fast fill for both LH2 and liquid oxygen. Again, we are in fast fill for both tanks in the upper stage of the Space Launch System. We got about 20 minutes left, it looks like, for upper stage loading. And then the team will look at starting the next milestone, which is the pre-press test of the core stage.
So Daryl Nail from NASA Public Affairs reports about 20 minutes remain in this loading of cryogenic liquid hydrogen, liquid oxygen into the upper stage. Also in this view, you can see the swing arms below the crew access arm. Below the crew access arm is the service module umbilical that connects to the service module of the Orion spacecraft. And there's the ICPS upper stage umbilical. That's where the propellants are currently being loaded into the upper stage right now. And then below that, there are additional umbilicals located at the top of the core stage. And then there's an intertank umbilical between the hydrogen tank and the oxygen tank on the core stage. And then we've talked a lot about the tail service mast umbilical at the very bottom of the core stage, where propellants flow into and out of the core stage tanks during propellant loading and draining operations. That's where this persistent, but now apparently manageable and within limits, hydrogen leak has been found in the quick disconnect on the 8-inch fill and drain valve on the hydrogen tail service mast umbilical. Again, that leak delayed the start of loading of hydrogen into the core stage this morning. It's the same area where a leak was found back on September the 3rd that scrubbed the second launch attempt for the Artemis 1 mission. And technicians repaired that leak by replacing a seal in that 8-inch quick disconnect fitting, where the line from the launch platform actually connects to the loading line on the core stage itself. Right at that interface is where the leak has been occurring at intermittent different magnitudes, sometimes out of limits, sometimes within limits. Right now, that leak is within limits. And under the 4% allowable constraint. If you're just joining our coverage of the Artemis 1 taking test, welcome. You're looking at a live shot of the Space Launch System moon rocket from a camera out at pad 39B looking east. The 98-meter or 322-foot tall Artemis 1 moon rocket is standing on its mobile launch platform in the final stages of propellant loading today. This is a tanking test designed to gather data and verify that hydrogen leak, persistent leak in the loading line at the bottom of the rocket at the tail service mast umbilical area has been resolved. The latest report on that leak from NASA's launch control team is that the leak is now manageable and within acceptable limits. So that's a promising sign. And loading of 22,000 gallons of cryogenic propellants on the upper stage is in the final phase right now. Here's a zoomed in shot on the upper stage area. The upper stage is near the top of this view. At the bottom, you can see the uppermost portion of the core stage. And then the launch vehicle stage adapter is that tapered conical section. And then just above that orange launch vehicle stage adapter, that white cylinder area is the ICPS, or the interim cryogenic propulsion stage, which is the upper stage of this vehicle. And another milestone still to come will be the pre-press test on the hydrogen fuel tank on the core stage. That will accomplish a milestone left unaccomplished during the wet dress rehearsal campaigns earlier in the summer. The team was not able to get to that pre-press test and pressurization milestone of the fuel tank during the most recent wet dress rehearsal back on June 20th because of a leak in a hydrogen bleed line associated with the chill down of the RS-25 engines. That leak has now been repaired. There's no leak in that system that's been detected so far today. And the pre-press test will actually allow the pressure inside that fuel tank to begin building up closer to flight level, the pressure that the tank will need to reach for engine ignition and the launch itself. That will involve closing vents to allow the pressure to build up in that hydrogen tank and then adding helium to that tank to further increase and ramp up the pressure. And the engineers on the launch control team will be carefully monitoring the behavior of the entire rocket during that procedure, during that test. Most notably, perhaps, they'll be monitoring the leak in that hydrogen loading line, because that pre-press test will actually add more pressure to that line. So they'll want to see if the leak rate increases as that occurs. Again, that'll be the first time that the tanks will be brought up to flight pressure during this Artemis 1 campaign, at least for the hydrogen tank. We're seeing these continued periodic views from the engineering cameras at pad 39B, showing up-close views of various parts of the rocket. The engineering team in the Launch Control Center is controlling these cameras for inspections of various parts of the vehicle. You can get a good close-up view here of some of the spray-on foam insulation, the thermal protection system for the core stage. This foam is similar to the foam that was used on the external tank of the space shuttle. It still has that distinctive orange butterscotch color to it, and it's used to minimize the buildup of ice and frost on the tank on the core stage as supercold propellants are loaded on board. And it also helps control the thermal conditions inside the tank to minimize boil off of those cryogenic propellants during the countdown. You may have also noticed the countdown clock continues ticking. It just passed T-minus 20 minutes. It's heading toward what we expect to be a built-in hold at T-minus 10 minutes. During a real countdown, that hold would be expected to last 30 minutes before the clock would resume at T-minus 10 minutes and counting to head down to liftoff. The plan for today's tanking test is to hold the clock at T-minus 10 minutes and not proceed into that final 10-minute terminal countdown. So the clock will stop at T-minus 10 minutes and remain there for the remainder of this tanking test. Here you see the liquid oxygen feed line. That's the that pipe there just to the right of that checkered pattern that runs the vertical length of the core stage from the liquid oxygen tank, which is at the top of the core stage, down to the engine section. That's where the propellants, the oxidizer, flows from the oxygen tank down to the engines to feed them during flight. And those there are 2 liquid oxygen feed lines. Those are also used to load liquid oxygen into the vehicle during tanking. So we're well into today's tanking test now, after some delays earlier this morning for the troubleshooting of that hydrogen leak, which is now manageable according to NASA's launch team. And we're waiting for confirmation now of the completion of cryogenic tanking on the upper stage. That should be one of the next calls we hear from the Launch Control Center. We've been tuning in to listen to Daryl Nail from NASA Public Affairs. He's relaying updates from the launch control team, which is stationed inside Firing Room 1 of the Launch Control Center, just next to the Vehicle Assembly Building at KSC. Every time we hear him provide an update, we're going to pause our commentary to listen to his updates directly from the launch team. T-minus 15 minutes and counting. We're about 5 minutes away from this expected built-in hold in the countdown clock at T-minus 10 minutes. We do expect the clock to stop there and remain at T-minus 10 minutes for the remainder of this countdown tanking test, practice countdown today. The countdown clock itself is not such a huge factor for this tanking test. Nonetheless, the clock has been ticking. It's a 2-day countdown for the Artemis 1 moon rocket, which began on Monday evening, late Monday afternoon at KSC. And the clock is, again, continuing down to T-minus 10 minutes and holding. and will be stopped there for the remainder of this tanking test today. During your real countdown on launch day, the clock would stop there for 30 minutes. And during that hold, Launch Director Charlie Blackwell-Thompson will poll her team for a go or no-go to proceed into the final 10-minute terminal countdown. And then the clock would pick up at T-minus 10 minutes and counting and head down to T0. During that final 10-minute terminal countdown, the rocket and Orion spacecraft would switch to internal power. The rocket's core stage auxiliary power units would power up to begin providing hydraulic pressure to the engine steering system on the bottom of the core stage. And also during that final 10-minute terminal countdown, the propellant tanks would be brought up to flight pressure, and then the RS-25 engines would ignite at T-minus 6 seconds, leading up to liftoff at T0, when the two powerful solid rocket boosters would ignite to propel the rocket off the pad. None of those activities will occur today during this tanking test. The only remaining milestones for this tanking test involve completing the loading of cryogenics on the upper stage, which should be nearing completion soon. Should be hearing that milestone completed soon. And then the pre-press test on the fuel tank on the core stage. So we'll stand by for reports on those milestones from launch control. While we're waiting for those updates, we'll invite you one more time to please subscribe to our YouTube channel, where you'll get alerts when we're going live for coverage of events like this tanking test, as well as all launches from Florida Space Coast from either Cape Canaveral Space Force Station or Kennedy Space Center. The next launch from Cape Canaveral, by the way, is scheduled for Saturday evening. That'll be another SpaceX Falcon 9 rocket carrying the next batch of Starlink internet satellites into orbit. That launch is scheduled for roughly 7:30 p.m. Eastern Time, or 23:30 UTC on Saturday night, and we'll be live here on YouTube for that. If you subscribe to our YouTube channel, you'll get an alert when we're going live. Also, please like this stream. It helps us gain a bigger audience for this coverage of this tanking test today. So if you haven't clicked the like button yet, please do that now. Countdown clock is at T-minus 10 minutes and 20 seconds. That should be stopping in the next 15 seconds or so at this built-in hold mark at T-minus 10 minutes. There it is, T-minus 10 minutes and holding. This is a built-in hold in the countdown. This is where the clock is expected to remain throughout the rest of today's tanking test. If this was a real launch day, this clock would be stopped here for a 30-minute built-in hold. And during that hold, Launch Director Charlie Blackwell-Thompson would poll her team for a go or no-go to proceed into the terminal countdown and launch. But again, no launch is scheduled today. And the countdown will also not go into that terminal phase today. It'll remain here at T-minus 10 minutes to complete the final objectives for this tanking test, which include the final loading, finishing of loading of cryogenic liquid hydrogen and liquid oxygen on the interim cryogenic propulsion stage. That's the upper stage of the SLS moon rocket, which has 2 tanks containing 22,000 gallons of propellant. And then the other milestone still to come is the pre-press test on the fuel tank on the core stage. Those are the main objectives still left unaccomplished so far today, but NASA's engineers are hoping to get those boxes checked in the coming hours here at Kennedy Space Center. And then once those are complete, the tanking test is expected to be declared complete, and the rocket will be safed and the propellants will be drained from the vehicle while NASA managers evaluate how to move forward, what their next steps might be. Those range from potential launch attempt next week, if everything goes well in the remainder of this test, or on the other end of the spectrum, if the Space Force doesn't approve a certification extension on the flight termination system batteries, the rocket may have to roll back to the vehicle assembly building for a recertification or retesting of those batteries, which cannot occur at the pad. That has to occur inside the VAB, inside the high bay of the vehicle assembly building. That would push the launch of Artemis 1 at least until late October, potentially even to the following launch period, which opens November the 12th.
Top of the hour, 3 p.m. Eastern Time. As you look
Here's
at the top
Daryl
of the
Nail
rocket,
from Launch
the
Control
Space
with
Launch
another
System
update.
At Launch Complex 39B. We're currently in the midst of a test to demonstrate the cryogenic loading of the world's most powerful rocket, the Space Launch System, the moon rocket that you see right there. Currently, you can see we are venting off liquid oxygen at the top of the rocket, venting both the core stage, which is fully tanked, and we're venting off the upper stage. If we go back to that upper stage shot, just want to point something out. You can see the venting from this wide shot, but as you look there, you see the 2 small plumes at the top. That's the vent for the liquid oxygen tank in the upper stage of the rocket. And currently, we've been loading liquid oxygen for about 54 minutes into the upper stage, and we're about half full. So a little less than an hour left to complete the final load in that. The upper stage LOX is a 53,000-pound tank, much smaller, but the flow that goes into the line is also not as fast as it is for the core stage. And then, of course, you see the plume in the lower, just below those upper plumes. That is the core stage liquid oxygen venting now. Just super cold gas condensing water in the atmosphere. That warm Florida air, which we're about 77% humidity. So lots to see there. And then you see the 2 small ones at the top venting out. Those are for the ICPS, the upper stage. Everything nominal and looking good there. In fact, there's a close-up shot of it. It's a great shot by our team here at NASA TV. And you can see the propellant lines that go into the ICPS. Those umbilicals pull away, of course, once we lift off the rocket. Today is a test, though, and a test only, going down to the completion of a pre-press test on the core stage, and then our test will be complete. We've got a little bit to go on the liquid hydrogen upper stage. That's about a half hour left. So we're looking good there. Everything proceeding nominally there so far for the upper stage. Just to recap on the lower stage, had a really smooth loading of the liquid oxygen tank on the core stage, but then on the liquid hydrogen, ran into a leak, had a stop flow. But then the engineering team warmed that line up in an attempt to reseat the hydrogen line that goes in and connects to a seal that's right against the flight plate there. They were able to get it, to get that leak to substantially reduce, and as they increased pressure, got it to the point where the leak started coming down, which is what they want to see. They've been managing that, and it's been all good from there. Tanked the entire liquid hydrogen tank on the core stage, and now both of those tanks are in replenish. Got a little ice there at the bottom of the two nozzles that we can see. Actually, we can see three nozzles, three of the four nozzles of the RS-25 engines. A little ice formation, not a problem, say the engineers. That's all normal. While we're looking at the engines, just want to make a note, those engines, as part of the Boeing core stage, engines are designed by Aerojet Rocketdyne. And those engines have a history going back to the Space Shuttle program. And just to name them off as you see them there, all the way to the left is Engine 3, which has the 4-digit identifier 2058. Engine 3 was involved in 6 flights during the Space Shuttle program, and all 6 of them were flights to the International Space Station. Behind engine number 3 is engine number 4 with the 2060 4-digit identifier. And 2060 was involved in 3 flights during the Space Shuttle program, including the last one, STS-135. Space Shuttle Atlantis, which launched from right here at the Kennedy Space Center in 2011. And then moving to the right in the foreground, that's engine number 2, 2056. It was involved in 4 Space Shuttle flights, including the Hubble Telescope Servicing Mission. Great mission that was. A lot of history there with that engine. And then last but not least, and not appearing in your picture, right behind engine number 2 is engine number 1, 2045. Engine number 1 was involved in 12 Space Shuttle flights, including John Glenn's flight, late senator and astronaut. And it was also on the final Space Shuttle mission. Quick engine history there. Thanks to the folks from Aerojet Rocketdyne for providing that information. Weather turned out to be good for today. Really good day for tanking. Had some storms offshore, but those were of no consequence to the loading operation. They moved right past that. You can see some clouds in the distance, even given some rain at this point, but launch weather officer is monitoring all of that. At this point, it's no impact, and we are green to proceed. The next step is the pre-press test of the core stage liquid hydrogen tank. And that is the final test of today's tanking mission. The pre-press test will involve the pressurizing of the LH2 tank and bringing it up to flight levels. So what this pre-press does is it mimics what happens to the LH tank in terminal count. They'll close the fill and drain valve. They'll terminate replenish. Pressurize that tank to flight levels, and then do a high flow bleed check. This high flow bleed will flow liquid hydrogen through those engines at the bottom to get them in the proper thermal condition for launch. Get them at the right temperature before they start flowing minus 423 degree Fahrenheit liquid hydrogen through there, along with liquid oxygen at minus 297. And when they combust, it'll be fast moving water vapor that'll come out of there, totaling about 2 million pounds of thrust. That's during launch. But the pre-press test, which is coming up, which will be a one-time test only. There's a big moment that launch team is looking forward here to starting up. It runs about an hour. Of course, we'll be tracking all the milestones along the way. Things are looking good here at the launch pad for the SLS rocket and today's test so far. That's all for now. This is Artemis Launch Control.
That was the voice of Daryl Nail providing updates from the Artemis 1 launch control team at Kennedy Space Center. We've heard that the liquid oxygen has been fully loaded onto the ICPS upper stage of the SLS moon rocket. Liquid hydrogen continues flowing into the upper stage. That will continue for nearly another hour or so. Once that is complete, the moon rocket will be fully loaded with propellant. And
when
again,
this
the other
rocket
remaining
is ready for launch, it will be the first in a series of increasingly complex missions. Artemis 1 will provide a foundation for human deep space exploration and demonstrate NASA's commitment and its capability to extend human presence to the moon and beyond. To learn more about the Artemis 1 mission and the Space Launch System, go to our website, nasa.gov/Artemis-Roman numeral 1. We are currently in topping for the liquid hydrogen tank on the ICPS in the upper stage there. Currently in topping for the liquid hydrogen tank on the upper stage of the SLS. A quick programming note. In just a few minutes, we are going to be switching our coverage here on NASA's main public TV channel to coverage coming from our friends at the Johnson Space Center, covering the Soyuz launch and docking to the International Space Station with its 3 new crew members. You see on your upper stage LH2 is in replenish. The upper stage LH2 tank is now in replenish. That leaves that leaves the liquid oxygen tank on the upper stage left to go, probably about 20 minutes or so. And upon completion of the liquid oxygen upper stage, it'll be time for the pre-press test. Okay, folks, a little early on this, but we just got the go from the launch director given to the liquid hydrogen team to proceed with the pre-press test. Again, the launch director, Charlie Blackwell Thompson, giving the go to proceed with the liquid hydrogen pre-press test. This pre-press test will pressurize the liquid hydrogen tank to flight levels. They're going to close off the vent line, terminate the replenish, and then start a engine bleed with high flow that saturates the engines at the bottom of the rocket to super cold temperatures that would be ready to receive a flow of liquid hydrogen and liquid oxygen through those engines for startup. This is an important moment, an important test for the team. So the LHY team will start a control loop that cyclically pressurizes the tank. They'll open the vent valve, which will help control the temperature. And if successful, it'll validate that pressure control algorithm. This pre-press test is critical for terminal count. During terminal count at T-minus 4 minutes and 40 seconds is when the high flow bleed will start for a launch countdown. It'll run about 4.5 minutes. It'll get the engines to exactly the right temperature for launch. Launch team to this point haven't been able to validate this procedure yet. They have the opportunity to do that now. This is Artemis Launch Control.
That was once again an update from Daryl Nail from Launch Control, confirming that the launch team is now go to proceed into one of the final steps for this tanking test, which is the pre-press test on the core stage of the Space Launch System to start bringing that fuel tank up to flight pressure, closer to flight pressure, and monitor how the system responds to that pre-press test.
Has begun on the LH2 tank. The core stage pre-press test has begun.
And that confirmation just now from Daryl Nail from Launch Control confirms that the pre-press test has begun on the liquid hydrogen tank on the core stage.
as the pre-press test is happening. The liquid oxygen tank, just an update on that, in the upper stage is continuing to load. The LOX tank in the upper stage is still loading. And welcome back to those watching NASA Television's public channel. We are live at the Kennedy Space Center in Florida for the final moments of a cryogenic demonstration test of the Space Launch System rocket. The final test, a pre-pressurization of the core stage liquid hydrogen tank. This is something that would happen in the final minutes of a countdown to get the engines ready to go. The tank is pressurized. A high flow bleed is drawn through the 4 RS-25 engines. And then once the temperature is right, the engines are lit. 6 seconds later, boosters ignite and the rocket lifts off. Today is just a test of a procedure that happens in the final 4 minutes and 40 seconds of terminal count. All is going well so far. LH2 core stage tank pressurization has begun. The replenish valve has closed. This is the one that replenishes liquid hydrogen as it boils off and just replaces what is lost. The fill and drain valve is now closed. This is the one that filled it to 100% or close to 100%. This is the 8-inch line right there. That's now closed. And the vent valve towards the top has closed, and so now the tank is pressurizing. Engineers watching the telemetry and data closely, as are we.
So we've heard from Daryl Nail from Launch Control that this pressurization of the core stage liquid hydrogen tank is underway with the closure of multiple valves, fill and drain valve and vent valve, to allow pressure to begin building up in that core stage fuel tank. This pressurization step would normally occur in the final stages, final minutes of a real countdown for the SLS moon rocket.
The leak at the QD. It went above its 4% hydrogen concentration threshold. But the team does have a contingency plan to allow that to happen for no more than 5 minutes. The tank continues to pressurize, and it is stable. The leak is stable at around 4%. CLOX just came in with a report that they have finished fast fill. That's the liquid oxygen in the upper stage. They are in replenish now.
That latest report from Daryl Nail at NASA Launch Control in Florida indicates that the hydrogen concentration in that tail service mast umbilical area has increased up to around 4%, which is the allowable threshold. But that leak concentration is reported to be stable around that 4% threshold, which again is the limit for a hydrogen leak in that area during a countdown. But the team does have permission to continue with today's operation and allow that concentration to increase up to 10% if necessary, in order to gather some data on the quick disconnect and tail service mass umbilical area's response to the increase in pressure. They want to monitor how that leak responds as different levels of pressure are applied to that loading line. Again, the hydrogen tank is pressurizing, so it's not entirely unexpected for that leak rate to increase during this pre-press test. But this is all part of the exercise to gather data on the performance of the overall system, specifically that troublesome liquid hydrogen connector at the bottom of the core stage.
update on the pre-press test. The engineering or the launch team has achieved the pressure they were looking for in the engines, the RS-25 engines, through the high flow engine bleed. They've got it to the proper delta P they were looking for. It's a tight range, but they've got it in spec. Big accomplishment there. You can see the cryogenic team in the middle there, monitoring the test. The test is now complete. The test is now complete. Again, there was a leak that was in the 4% range. This is from the quick disconnect, 8-inch QD right there at that location, but it was stable throughout the test, which is a good sign. Stand by.
That was once again the voice of Daryl Nail from Artemis 1 Launch Control at Kennedy Space Center, confirming that this pre-press test on the core stage liquid hydrogen fuel tank is complete. The team hit the expected pressure parameters they were looking for.
Liquid hydrogen team is preparing to get back into loading the core stage. Part of this pre-press test is they closed off the fill and drain, which is basically the fuel line that puts liquid hydrogen right there at that location. Now they're going to reopen that valve to put back the propellant that was lost while they had it closed up and pressurized during the test. With the pre-press test complete, the LHY team now wanting to get the upper stage into replenish. And we are back in replenish on the core stage. The core stage liquid hydrogen is now back in replenish. The team working now on the upper stage that you see there. Trying to get that upper stage LH2 dialed in. There's a loop that adds propellant, and it's gone over the amount. And so they're just trying to get that calibrated so that it settles the LH2 tank at exactly 100%. They're currently working that right now. I need to correct some information about the hydrogen leak that was observed during the pre-press test. That was on the 4-inch QD for the engine bleed line. Again, that was for the engine bleed. It was a stable, but different leak, not on the 8-inch fill and drain. 8-inch fill and drain was isolated. It wasn't in play. But that leak was observed in the 4-inch QD quick disconnect on the engine bleed.
That most recent update from Daryl Nail from Artemis Launch Control at Kennedy Space Center clarifies a piece of information we relayed to you earlier about this leak that was observed during the pre-press test on the core stage fuel tank. This leak that was observed a few minutes ago is in a 4-inch bleed line, a quick disconnect in a 4-inch bleed line in the hydrogen system on the core stage fueling system. This is a separate connector from the 8-inch quick disconnect fitting that leaked earlier in the countdown. That leak, NASA now believes they have under control. They said it was quote unquote manageable and under the 4% hydrogen concentration limit. This most recent leak observed in the pre-press test did reach close to that 4% limit, but was reported to be a stable leak. It was not spiking far above that limit. So a bit of a clarification there from Artemis Launch Control and launch countdown commentator Daryl Nail here at Kennedy Space Center. Here's a view on the left side of your screen of the tail service mast umbilicals connecting the launch platform with the core stage. Propellants flow into and out of the rocket through those connections. On the left is the umbilical lines for the liquid oxygen system. On the right is the umbilical connection for liquid hydrogen. That's where the 4-inch and 8-inch lines are located that have been leaking today. Again, NASA says these leaks have been relatively stable. So we're not sure how to really interpret that. Given that this most recent leak was near the 4% limit. So clearly there still is an issue with these leaks. But after an initial spike up to 7% earlier this morning at the very beginning of hydrogen loading, these leaks appear to have been stabilized to near or below the 4% limit over the last few hours. Of course, NASA managers will closely analyze all the data from this tanking test as they decide how to move forward. And the options range from a launch attempt potentially as soon as next week on September the 27th. That's the earliest this Artemis 1 mission could have its next real launch attempt. And on the other end of the spectrum could be a rollback to the vehicle assembly building for any additional troubleshooting of this hydrogen leaks rather, in the tail service mast umbilical, as well as potential rollback to retest and recheck the flight termination system batteries to extend the certification of those batteries. And that would assume that the Space Force does not approve a request from NASA to extend the certification of those batteries for another series of launch attempts. Those batteries power the flight termination system. It's an independent power source for this range safety destruct system, which would need to be active and providing power to the destruct system, even in the event of a catastrophic failure of the SLS moon rocket after liftoff. This destruct system is needed for public safety purposes to destroy or blow up the rocket, essentially, if it veered off course and threatened any populated areas after launch. So this is a very critical system. The range team takes their responsibilities seriously, and they're evaluating whether they're comfortable extending the certification of the battery life on the FTS batteries on the Space Launch System. If the rocket has to roll back, that would likely delay the Artemis 1 launch until late October or November. While we continue monitoring the final stages of this tanking test at Kennedy Space Center, we'll ask you once again, if you haven't hit the like button on our stream, please do hit that like button to help us gain a bigger following for our coverage. That really helps us a lot. Also, if you haven't become a subscriber to our YouTube channel, you can subscribe and get alerts when we're going live with launch coverage. So please do that as well if you're interested in watching future coverage of launches. Again, the next launch we'll be covering live on YouTube will be on Saturday. That's the scheduled launch of a SpaceX Falcon 9 rocket from Cape Canaveral Space Force Station, with the next batch of Starlink internet satellites will be going live Saturday evening in advance of a liftoff from Pad 40 at Cape Canaveral that is set for around 7:30 p.m. Eastern Time or 23:30 UTC. Again, that launch of a SpaceX Falcon 9 is scheduled for Saturday evening at Cape Canaveral Space Force Station.
Okay, the cryo team just updated the NASA test director on the results of the pre-press test. Currently, we are back into nominal auto-replenish for the core stage liquid hydrogen tank. That's good news. Engineers report that the pre-press test went very well. They were able to dial in the bleed position on those engines. The pre-press control, in fact, got them dialed in pretty quickly. You may remember I mentioned this test was scheduled to take about an hour, and it took far less than that, less than 15 minutes. Engineers say that that pre-press control got them dialed in pretty quickly, and they were able to raise and lower the pressure within the range, within the desired range, just to get a feel for its limits and how it moves within that range. So it went really well. They've got that part dialed in. The liquid hydrogen team also addressed the increase in concentrations of hydrogen detected during the pre-press. This is the leak. So they reported it got up to a little over 5% in the cavity. This is likely the 4-inch bleed QD. This is the line that carries the liquid hydrogen out of the engines after they've run through the engines and super chilled them. They saw it go a little over 5% during max pressure on the bleed system, but as the flow continued, they reported that the leak rate lowered on its own through no input on their side. If we were in terminal count, which is what this was testing, it would have been a violation and stopped the count, but for the ground rules that were set for today, they were within those, and the launch team's looking forward to getting back that data and taking a close look at it. Currently still dialing in the LH2 load on the upper stage. Still working that replenish in the upper stage, but the hydrogen team reporting that they're almost done with that. And so we're looking to get confirmation of that. Once we do, we've asked Charlie Blackwell Thompson, the launch director for the Artemis program, to come in and give us a report, and then we'll close out the show. She's currently talking to the launch team, as you can see there, next to her assistant launch director, Jeremy Graber. We'll look forward to talking to her in just a bit. For now, this is Artemis Launch Control.
We're continuing to stream live views from Kennedy Space Center showing NASA's Space Launch System moon rocket. It's now 4:17 p.m. Eastern Time here in Florida. That's 2017 UTC. On the left-hand side is a view from an engineering camera on the mobile launch platform. This is from the side of the rocket that has the launch platform tower, looking at the base of the core stage with those 4 RS-25 engines visible there, with the 2 powerful solid rocket boosters on each side. On the right is a camera shot from the KSC press site, about 3.5 miles away from our position, where we'll be covering the Artemis 1 mission. With this tanking test now in the final stages, we expect to hear from Launch Director Charlie Blackwell Thompson. She will be joining Daryl Nail from NASA Public Affairs sometime soon, hopefully in the coming minutes, for an interview to review how today's test went, the results of today's test, which so far seem from an external point of view, seem to be fairly favorable. However, with a few issues, including the hydrogen leak, 2 different areas where there's been a hydrogen leak observed today, in a 8-inch quick disconnect and then in a 4-inch quick disconnect. So the team will have to take a really close look at how these leaks manifested, how the team was able to manage them before deciding whether to proceed into another launch attempt for Artemis 1, perhaps as soon as next week. While we wait for further updates from NASA Artemis Launch Control, here's a look at the launch opportunities available to NASA in the current Artemis 1 launch period, known as Launch Period 26. This launch period opened 2 days ago on the 19th of September, Tuesday, and runs until October the 4th. And this chart shows the launch times and launch window durations for this launch period. The very earliest NASA could make the next launch attempt, assuming they're satisfied with today's test and assuming the range extends that flight termination system battery certification we've talked about, would be September the 27th. That's next Tuesday, when the launch window on that day would open at 11:37 a.m. Eastern Time or 15:37 UTC and extend for an hour and 10 minutes. So 11:37 a.m. Eastern Time next Tuesday, September 27th, is the very earliest NASA can make another launch attempt for Artemis 1. Again, like I mentioned, there are a couple of caveats with that. That range certification of the batteries on the flight termination system and the data review coming out of this tanking test. And NASA managers will review the data and results of today's test to determine if they're comfortable proceeding with another countdown, another launch attempt. This will be the third launch attempt for Artemis 1. If the launch doesn't occur the 27th and the team does proceed with another launch attempt this launch period, the backup day would be tentatively set for October 2nd. You see that date, October 2nd, on this chart, with a launch time of 2:52 p.m. Eastern Time, 18:52 UTC, and a window duration of 109 minutes. Theoretically,
okay, we got an update now.
Well, we have an update from Daryl now.
The liquid hydrogen team reporting that they were able to get their replenish loop dialed in, successfully making some adjustments to that, and they're happy with that. And so they're reporting a successful completion of that objective and all objectives for the test today. Launch Director Charlie Blackwell Thompson just completing a conversation on the loops with the launch team. And they report to her that they met all of the test objectives for today's cryogenic demonstration test. At that point, a go for cutoff was given, and that puts the ground launch sequencer into a safing sequence, which comes just before they begin detanking the vehicle, draining it of all of its super chilled propellants, all 4 tanks in the upper stage, the 2 tanks in the upper stage, and the 2 tanks in the core stage. Good news there all the way around. Charlie Blackwell Thompson now getting ready to do a debrief for their team, while we await a final closeout interview for our broadcast today. Stand by. This is Artemis Launch Control.
That was Daryl Nail again, reporting that the launch team has determined that all of the test objectives for today's cryogenic tanking test have been accomplished. Again, this tanking test was not leak-free. There were a couple of hydrogen leaks detected in the 8-inch and 4-inch quick disconnect fittings around the tail service mast area. After initially spiking above the allowable limit of 4% concentration, those leaks, that leak in the 8-inch line was now determined to be manageable by the launch team and stay below the 4% threshold for the remainder of the countdown after some troubleshooting. And then during that pre-press test on the fuel tank, the hydrogen tank on the core stage, the team detected a leak that reached near the 5% level in the 4-inch quick disconnect, part of the bleed line system on the tail service mast umbilical area. That is above the 4% limit. However, the leak rate decreased over time as the pre-press test continued and stabilized, according to NASA. So a lot of data for the engineers to chew on over the coming hours and days before deciding whether to proceed with the launch attempt next week. Again, if they decide to proceed with the launch attempt, they're targeting no earlier than September the 27th. That's next Tuesday. The launch window on that day would be opening at 11:37 a.m. Eastern Time, as you see here in this chart, with a 70-minute window duration. I was saying before the previous update from Daryl Nail that theoretically all of these dates going forward in late September and early October are available, just from a physics point of view and orbital dynamics point of view. But there are some constraints on the range with other launches, as well as a need to replenish cryogenic storage tanks out at Pad 39B between launch attempts. So if the team decides to go forward with the launch attempt next Tuesday, September the 27th, that would set the backup opportunity for October 2nd, as you see here in this chart. The launch team, the Artemis team, could decide that they need to roll back to the vehicle assembly building. For example, if the range does not extend the certification, does not approve the request submitted by NASA to extend the battery life certification on the flight termination system, NASA will be required to return this rocket to the vehicle assembly building for a recheck and a complete end-to-end test of that flight termination system. That can only occur while the rocket's in the VAB, cannot occur with the rocket at the pad. If that happens, the launch would certainly slip at least until the end of the late October launch period, which opens October 17th and closes October 31st. And there's a possibility, if they have to roll the vehicle back to the VAB, the Artemis 1 launch could actually delay into the following launch period in November, launch period 28, which opens November the 12th. So here are the launch dates for launch period 27 with the times here provided by NASA for each day's launch window. And then there's another launch period available opening November 12th. We're standing by for an interview that's to be conducted by Daryl Nail from NASA Public Affairs at Kennedy Space Center. He'll be talking to Charlie Blackwell Thompson, the Artemis 1 launch director, who's been working throughout the day inside firing room one of the Launch Control Center at Kennedy. She is in charge of all the launch countdown operations for Artemis 1. And she'll be offering her thoughts on the outcome of today's cryogenic tanking test. We're standing by for that interview, and we'll bring it to you live when it happens. Again, we're standing by for this post-test interview with Launch Director Charlie Blackwell-Thompson. It'll be conducted by Daryl Nail from NASA Public Affairs at the Launch Control Center. We expect to hear the words and thoughts from the Launch Director on the outcome of today's tanking test.
This is Artemis Launch Control at the completion of the Artemis 1 cryogenic demonstration test. I'm Daryl Nail with NASA Communications, and with all of the test objectives met, we have Charlie Blackwell-Thompson with us, the launch director for the Artemis mission. Thanks for being here, Charlie. Charlie just wrapped up comments with her launch team after a long day of testing and a challenging day at times, but overall, a lot of success. I want to get your thoughts, Charlie, on how the test went in your mind.
Well, I think the test went really well. We went into this test, we wanted to learn, we wanted to evaluate the TSMU, the LH2 TSMU under cryogenic conditions, understanding that we had done both an 8-inch and a 4-inch seal removal and replacement out at the pad. And we got into our loading operations. We had a new loading procedure that we had in place. It was very purposeful in the way in which we went through the loading ops. We wanted to be, we called it kinder, gentler, where we really monitored the temperatures and the pressures across the interface. And once we got into what we call our fast fill operations, we did notice as the pressure came up that we did see a leak in the plate cavity at the 8-inch QD. We went through our pre-planned. We have utilized it a couple of times where we stop flow and we allow it to warm up and then we reinitiate. When we reinitiated flow, we began to raise the pressures back up to get back into a fast fill configuration, and we were successful in that. So we did not see the same leak signature, which was wonderful. It allowed us to go through our loading profile all the way to core stage replenish. We also loaded the upper stage today as well, went through our Kickstart Bleed, went through our pre-press test. So all of the objectives that we set out to do, we were able to accomplish today.
And it was impressive just to watch and take in and listen to the engineers as they work through those leaks. Again, just impressive work. I wonder what your thoughts are on these seals, which, as you mentioned, were replaced. You're learning a lot. There's a lot of data yet to look at. What are your early thoughts about how they're behaving and what a path forward might be?
Well, I think you got to always take the data and go look at what it tells you. One of the pieces of data very encouraging to me was as we raised the pressure, we actually saw the leak go down. And,
on the 8-inch QD.
Yes.
Yep.
And so this is a pressure seal, pressure assisted seal. So that was very encouraging. And then, we saw the leak rate really taper off. So we'll go take all the data from this event, the early data, the data all the way through loading, through our pre-press test. The engineers and the team will go take a close look at that and evaluate what we learned today. And then we'll certainly be applying that as we get ready for launch.
The big question is, as you just mentioned, getting ready for launch. What does that mean? And what are the chances for a launch here on the 27th?
Well, I think we'll take the data and we'll go see what it tells us. I am extremely encouraged by the test today, getting through all the objectives, and we're setting up in our scrub turnaround to begin replenishment ops in preparation for our launch day. Like I said, we'll go take a look at the data. I think I don't like to get ahead of the data. And so I'd like the team to have the opportunity to go look at it, to see if there are changes we need to make to our loading procedure, our timelines, or if we're, good as is. But I'd like the team to have an opportunity to look at that before I speculate.
And last question on the team itself. As we encountered that first leak, you could kind of feel the room deflate just a little bit. And then as they worked it and got past it, there was a lifting, so to speak, of the room. Talk about kind of what you went through when you were observing this and what you saw your team and how they reacted.
Well, I'm really proud of the team. I think they reacted well. You're going to be disappointed when you see a leak, and I think that's normal. But what they did is they went and looked at what are our contingency procedures, what do we have in place, how do we work our way through it, and they went through those ops just as I would expect them to do. And we were successful in managing our way through it. And you're right, as we began to see that those contingency procedures were successful, certainly there was a lift within the room. But I couldn't be more proud of the team today and the work that they did.
And so now you march on and get that data, take a look at it, and see where it leads us. Charlie Blackwell-Thompson, Launch Director for Artemis, appreciate you being here. Thanks for taking the time. And that'll wrap it up for us here at NASA TV and the Kennedy Space Center. Our test coverage complete today. And stay tuned to all of our social media channels for more information and updates about where we go from here. I want to just say that with regards to the Artemis program, it is a new era of lunar exploration. NASA and its partners will lead humanity forward to the moon and prepare us for the next giant leap, the human exploration of Mars. If you'd like to learn more,
That was Daryl Nail from NASA Public Affairs speaking from Launch Control. He was interviewing Charlie Blackwell-Thompson, the Artemis 1 launch director, on the outcome of today's cryogenic tanking test. She mentioned that she was extremely encouraged with the outcome of the test and the results today. They did encounter a leak in the 8-inch hydrogen quick disconnect fill and drain line where the tail service mast umbilical connects to the core stage. That leak initially exceeded the 4% allowable limit. However, after some troubleshooting and allowing that connector to warm up closer to ambient temperatures and then reapplying pressure to that system and resuming the load of hydrogen fuel, the leak became manageable and remained below the 4% allowable limit for the rest of the day. There was later, during a pre-press test to bring the core stage fuel tank up to flight pressure, close to flight pressure, another leak that was detected in a 4-inch bleed line quick disconnect fitting. That leak briefly raised above the 4% allowable threshold, but it too became manageable and decreased in magnitude back below the 4% limit. So Charlie Blackwell Thompson mentioned she is, again, extremely encouraged with today's test, but NASA managers and engineers will chew on the data over the coming hours and days to determine whether they'll be able to proceed with the launch attempt next week. That launch opportunity is currently penciled in for no earlier than Tuesday, September the 27th. That date has a 70-minute window available, opening at 11:37 a.m. Eastern Time, or 15:37 UTC. So we'll await a word in the coming hours or days on whether that launch attempt will be possible. The other unknown right now is the range decision from the Space Force on the battery certification extension that's been requested by NASA for the flight termination system. This is the range safety destruct mechanism on the rocket that would be used to terminate the flight, essentially blow up the vehicle if it veered off course and threatened any populated areas. That certification expired earlier this month, but NASA has requested an extension and is providing data to support that proposal to the Space Force, which will make the final determination on whether that extension will be granted. If the extension is not approved, the Space Launch System will have to return to the vehicle assembly building for a full end-to-end retest of that flight termination system. That would delay the launch of Artemis 1 until at least late October, perhaps until November. So NASA officials hope to get that approval from the range in the coming days to allow a launch attempt to proceed next week. So still some uncertainties involved in when NASA will be able to schedule the next Artemis 1 launch attempt, but the opportunity to launch next week still remains in play, as NASA is extremely encouraged, according to Launch Director Charlie Blackwell Thompson, with the outcome of today's cryogenic tanking test. The next step will be the draining of cryogenic propellants from the Space Launch System. That will take several hours throughout the evening to drain the tanks, and then those tanks will be inerted. And then once that's complete, overnight into tomorrow morning, the ground crew will be permitted to return to the pad and resume their work. Launch Director Charlie Blackwell Thompson also mentioned that the team is going to replenish liquid hydrogen and liquid oxygen storage tanks out at pad 39B to set up for that possible launch attempt next week. So at the conclusion of today's tanking test, we're going to sign off from our live commentary. Check our webpage at spaceflightnow.com later this evening for a full recap report on the tanking test and the options moving forward for NASA's Artemis team as they prep for a next launch attempt, again, possibly as soon as next Tuesday, September the 27th. No final decision yet has been made in that regard. We'll stand by for news from NASA, and we'll bring that to you on our social media channels and on spaceflightnow.com when we get it. In the meantime, I'll remind you once more, if you want to join our YouTube channel, become a member, you'll be supporting our continued launch coverage here on Florida's Space Coast. You can join our YouTube channel. We have several membership levels available for you to choose from, depending on which level you select. You can gain access to exclusive video features from our coverage here on Florida Space Coast. This also helps us continue and maintain our nearly 23-year run of coverage of the space industry around the world on Spaceflight Now. So if you can support us in this manner, we'd really appreciate it, and we greatly ask that you please consider contributing and becoming a member of our Spaceflight Now YouTube channel. Also, you can subscribe to our YouTube channel. That's free to do. That's free. And you'll gain alerts. You'll get alerts when we're going live with launch coverage. Our next launch will be streaming live from the Cape. Is scheduled for Saturday evening, when a SpaceX Falcon 9 rocket is set to launch from Pad 40 with the next batch of Starlink internet satellites. That launch is scheduled for around 7:30 p.m. Eastern Time or 23:30 UTC. So with that, I hope you've enjoyed our coverage today. I'm Stephen Clark, editor of Spaceflight Now. We've been reporting live with views from the Kennedy Space Center today for the Artemis 1 tanking test. Again, thank you for joining us, and we'll see you next time.